في
Bismillahirrahmanirrahim. Distinguished guest speakers, chair, co-chair, and dear participants, Assalamu alaikum and a very good morning. I, Javina Pawada, Program Officer, warmly welcome you all to the second day of this OIC COMSTECH SUN and General Directorate of Water Management Training on Water Governance and IWRM Principles, Practices, and Tools. It is truly encouraging to see such enthusiastic participation from experts, professionals, and young researchers from the OIC member states who are keen to strengthen their knowledge, enhance their technical capacities, and contribute towards sustainable and integrated water resources management in their respective countries. We will begin today's session with the recitation of Holy Quran.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الرحمن علم القرآن خلق الإنسان علمه البيان. الشمس والقمر بحسبان والنجم والشجر يسجدان. والسماء رفعها ووضع الميزان ألا تطغوا في الميزان وأقيموا الوزن بالقسط ولا تخسروا الميزان. صدق الله العظيم.
Today's program consists of two technical sessions that address some of the most pressing challenges and emerging opportunities in the water sector. The sessions will focus on hydrometeorology, climate change adaptation, disaster management, water efficiency, digital solutions, and cross-boundary water governance. At this moment, it is my honor to invite the chair and co-chair of session 3, hydrometeorology and climate change. Our chair for this session is Dr. Ahmed Kamal, former chairman, Federal Flood Commission, Pakistan. And the co-chair is Dr. Shehbaz Altaf, assistant professor, NAS, Pakistan. Dr. Ahmed Kamal is presently member board of directors of Global Climate Impact Studies Center. Ministry of Climate Change is a seasoned professional in the field on water resources management and disaster management. Also, he is a chairman Federal Flood Commission, Ministry of Water Resources, Government of Pakistan from 2017 to October 2024. He is recipient of JICA International Presidential Award of Recognition in the field of disaster management, UNESCO IHE Award of Recognition. So welcome, sir, to this. And our co-chair, Dr. Shehbaz Altaf, is an assistant professor of urban and regional planning at the National University of Science and Technology in Islamabad, Pakistan. His work is widely published in top-tier journals like Ecology and Society and Society and Natural Resources, and he frequently presents his findings at global platforms. Thank you, sir, for joining us. So I respectfully invite to take over the proceedings of this session.
Bismillah Rahman Rahim, in the name of the Almighty Allah, the Beneficent and the Most Merciful. I am grateful to the organizers for giving me this opportunity to be the chair for this session, which basically is a very important topic, hydrometeorology and climate change. And we know that both hydrometeorology and climate change are interrelated, and how well we are well equipped with regard to hydrometeorological science and its implementation around, we can take care of the best climate change happening on ground. The region in general and Pakistan in particular has been experiencing that climate change impacts very visibly, predominantly from 2010 onwards. By virtue of that, we had faced 2010 floods, 2015, 2014 floods, and then 2022 and 2025. And all these floods have resulted in about 70 million of displacement all over the country, meaning thereby about 1/3 of the population of the country got affected by virtue of that. We have got a varying atmospheric or temperature variation on the ground. There is much more impact of westerly waves on Pakistan now. By virtue of that, superimposing on the monsoonal effect, we are getting much more flash floods. As this year, we are expecting a super El Nino to hit the region and the globe at large. There is a prediction by the Met Department that we are going to have much more high temperatures in our northern areas, maybe to the tune of about 41 to 44 degrees centigrade. And the same is going to happen in the upper Punjab as well. This means that we should be expecting much more blow events, and having all this context on ground. The importance of hydrometeorology, the importance of hydrometeorological equipment, the importance of hydrometeorological science has increased paramountly. Having said that, I would now like to introduce the speakers for this important session. We have got 4 talks in this session, and the first one is titled Climate Change Adaptation and Hydrometeorological Disaster Management, and it is going to be given by Professor Dr. Muhammad Sirajul Islam. He is a prominent scholar who served as a professor in the Department of Civil and Environmental Engineering and the director of the Center for Infrastructure Research and Services at North-South University. He is also the member of Board of Accreditation for Engineering and Technical Education, the Institute of Engineers Bangladesh, and he is also the fellow of the Institution of Engineers Bangladesh, besides reviewer of IPPC for 1.5 degree and AR6 reports. May I invite Professor Dr. Mohammed Sirajul Islam for his talk, for his presentation. Over to Dr. Saab.
No, sorry, let me. Assalamu alaikum, everybody, and a very good morning. Thank you for inviting me for this particular training session of water governance and IWRM principle, practices, and tools. I really appreciate the COMSTECH initiatives. I had the opportunity to offer a lecture by my last year, actually, and I'm really delighted that COMSTECH have arranged another program. As the speaker said, I am a professor of the Department of Civil and Environmental Engineering, North South University. So today I would like to divide my presentation into several parts: climate change, global trend, flood in South Asia, the causes, the management practices, and some examples of Bangladesh. The time is limited. As much as possible, I will try to cover. So first of all, let us mention very briefly that role of water in human life and civilization. It's a source of life, shaping the earth, development prerequisite, its moderate climates, and diluting pollutant nutrient cycle, and many more. Most of the ancient civilization actually grew near water bodies. The Egyptian on the bank of Nile, the Roman on the bank of Tiber, Mesopotamia, China, and Pakistan. The great civilization of Indus actually developed on the bank of the river Indus. India also on Ganges. Now, the factors that shaped global civilization, obviously water has played a role. Let me explain that global temperature changes, the highest temperature in 0 degrees centigrade and lowest around 90 degrees. However, in that case, the desert should be located along 0 degree because temperature is the highest. But however, it doesn't, even though it's an important climatic factors, but it doesn't play the main role because the global water availability, the precipitation nature all over the world varies differently. The precipitation over the world along the latitude varies like this, that 0 degree has the highest degree of precipitation. Here has a tendency to go up, low pressure zone. 30 degree north and 30 degrees south is known as high pressure zone. Here has tendency to go down, and it is very dry, descending cool dry air, so there is no precipitation. On the other hand, 60 degree again we have little bit of precipitation, not as much as 0 degree, but yes, good amount of precipitation. So if we compare this temperature variation versus precipitation variation, ultimately this precipitation variation affected the global distribution of biological community, ecosystem, and diversity. As you can see that along 0 degree, even though it should have the highest temperature, the most diverse ecosystem, the tropical rainforest, Amazon rainforest, mid-African rainforest, Sahara, all are located near 0 degree. On the other hand, at 30 degree north and 30 degrees south, we have all the deserts located: Sahara, Kalahari, Mojave, Australian, mid-Australian deserts. These are located. Why? Because the precipitation is low. Why highly diverse ecosystem? Because precipitation is high. So water played a very important role shaping the art, civilization, and development. Now the conference has a term IWRM, Integrated Water Resource Planning and Management. This is also an important term. Very recently we have started to understand the importance of IWRM. The term integrated here is very important. Actually, through doubling principle, probably one of the basic understanding of IWARM has been given or defined. That water is a finite, vulnerable, and essential resources, essential to sustain life, development, and the environment. Water resource development and management should be based on participatory approach involving users, planners, and policymakers, and then women, and then what are the few other issues. Here, one important issue that emphasizes the participatory approach and collaboration among different countries, because the water bodies actually move among countries. You might have heard that we are suffering from water sharing issue between upstream country and downstream country, both India and Pakistan. So integrated water resource management always emphasizes on this particular issue of participatory approach. IWA is a process which promotes the coordinated development and management of water, land, and related resources in order to maximize the resultant economic and social welfare in an equitable manner without compromising the sustainability of the vital ecosystem. So these are some definitions that which means that the solving water problem is cannot be dealt in a piecemeal manner. The term integrated is here very important, and it comes with economy, it comes with social dimension, it comes with environmental dimensions, and it comes with the importance of integrating factors. Integrated resource and planning and management is actually a highly complex due to a number of reasons, because highly affected by natural variation or uncertainties. Well, whenever we are dealing with water, we are always dealing with uncertainties. I cannot design a structure with certain flow, and then I can assure that next year the same amount of flow in the river will be available. Similarly, I cannot say that next year I will have the same amount of precipitation. So our management, our study, all of our activities are associated with uncertainty. That is stochastic process, not the deterministic process. We rarely can define any of the process or any of the structures through deterministic process. It's a very stochastic process. A large number of stakeholders with conflicting interests. This is another important issue. A large number of stakeholders. There are agriculturists, they need water. There are people from navigation, they need water. There are people from domestic sector, they need water. Then the river itself needs environmental water. So there are conflicting interests. It sounds like this, that there is a river and everybody is trying to get water from it. Stakeholders involved in river basin planning. Most of the rivers or water bodies flow through different administrative regions like country, province, so that water sharing is a problem. Obviously, the country to country is a problem, but sometimes even province to province we have problems. Not only technical factors, so environmental factors also play an important role, sometimes even political issues. Decisions in the context often affect the distribution of benefit over different social groups in a society, and even might affect. I mean, it's a very complex issue. What has become a strategic resource and diplomatic as well as a trigger to social and political stress. Most of the environmental issues are related to water, climate change, flood, drought, deforestation, and water pollution. So, integrated water resource planning and management is a very difficult and very complex issue. Now, how climate change can play a role there? This is an important issue. We very simplified dimension of relationship between different factors. Like population is an important factor, socio-economic factor. Population increasing, so demand for water increase. Economic condition increasing, the per capita water demand increase. And whenever this per capita water demand increase, total demand increase, stress on water resources. Per capita water demand increase, water quality will be affected. So like this, it's a very complex issue. As you can probably you know that there is a term called Falkenmark Index. The water experts, all of us know it. That Falkenmark Index gives us an idea about the stress level of a country in terms of its water availability. According to Falkenmark's index, the relative sufficiency, the country is not having any water stress. As I told you, the socioeconomic factor is a very important factor here, population. Greater than 700 meter cube per person per year. It's a country with relative enough water. A country below 1700 meter cube per person per year, intermittent, localized shortage of fresh water. A country below 1000 meter cube per person per year, chronic and widespread freshwater problems, absolute scarcity when it is 500 meter cube per. Unfortunately, Bangladesh has quite a good amount of water, but unfortunately, we have a strong seasonality. I will explain later. We have water when we don't need water. We have no water when we actually need water. That is also a problem. So anyway, these are some definition. And already these are the countries which are suffering from water shortage all over the world. Water scarce countries, and presently in 1995, 2025, and 2050, these are at around 4 billion people may suffer from water shortage or water stress. And that's why there was a famous saying by the then UN Secretary General Kofi Annan that next global war could be on water. So water stress is really a major issue. Now, the next important issue is climate change. And it's like there is a problem and it is getting further aggravated due to another factors, and that is climate change and natural disaster. Climate change is further aggravating the problem related to water resources as well. Already we have stress and all these things, but climate change may further aggravate the problem. Now let us see, especially in terms of natural disaster as well as drought as well. Today maybe we'll talk about flood mostly, but drought may also aggravate. Let's see some of the cases, some of the recent incidents that occurred in South Asia. From 2022 to 2025, in South Asia, we have experienced a number of flooding events. In 2025, Pakistan severely affected. In 2024, Bangladesh also affected. In 2020, Sri Lanka and India affected. In 2022, Pakistan, India, Bangladesh, Afghanistan, all of this. So almost every year there are flooding events. So the question arises whether there is any relation with climate change. Why it is happening? Why the issue is getting aggravated day by day? Unfortunately, South Asia is very much prone to climate risks and climate-related natural disaster. This was one of the latest report by CRI, published in 2020 or 21 probably. After then, they published at regular 10 countries were identified as the most vulnerable in terms of climate risk. As you can see that 3 of them are from South Asia. So this is very condition is very bad. Sorry, I'm not sure because Turkey is involved, but I had an idea that probably South Asia is the main concern. But anyway, the same may be the case for other part of the world as well. And in terms of flooding, another study by probably UNDP, you can see that flood, Afghanistan, Pakistan, India, out of 6, 4 of them from South Asia. Natural disaster, especially water-related disaster, trend is actually increasing all over the world. This is flood, the middle one, and this is hydrological disaster, increasing day by day. And it is at a steeper rate with slope than other natural disasters. And Asia is going to be one of the most severely affected regions. As you can see, 1970 versus 2030, the changes in affected people. Asia, a huge number of people. Maybe the increasing people itself is more than the number of people affected all over the world. Now let us see that well, Asia severely affected by where, which part is South Asia, and unfortunately my country is Bangladesh. This is a global assessment report on disaster risk reduction by UNISDR, very recent, maybe 2-3 years back. So we can see that South Asia and this part of the world, and especially flood-related, water-related disaster is increasing day by day. Now, to define climate change and natural disaster, interrelationship between climate change and natural disaster, we try to explain it with one model that is known as HEVR model. We said HEVR model. You know, many of you, that disaster is a function of hazard or the natural event. Then how many people, what are different types of resources exposed to that disaster, and then what is the coping capability of that particular community, the vulnerability with, are they poor, are they educated, are they well, are their building properly designed, how many people are exposed, is there any zoning policy? So this is known as STREX model, HEVR. So I'll try to explain from that point. Now, actually, STREX this is the report, IPCC report, where it has been proposed. And fortunately, I had the opportunity to serve this report from Bangladesh as an expert reviewer. As you can see, my name is there. It's an IPCC Intergovernmental Panel on Climate Change. And also, I have worked for 1.5 degree, as you can see that from Bangladesh. I actually worked for 6 IPCC report at under different capacities. So now, what is HEVR model? This is HEVR model. H is the naturally occurring incident. Let's say the velocity of wind or the height of water. That is actually H. What is exposure? Exposure is the number of people, number of building, number of the acres of land for agricultural land. There is exposure. Vulnerability is the factor that is education, then poverty level, preparedness, all these things, and finally we'll decide. Now, what I could see summarize about South Asia, the why the disaster is getting more severe. Let's say there is a cyclone in Bangladesh versus there is a typhoon in Japan. How many people will be affected? Or there is a earthquake in Dhaka versus there is an earthquake in Tokyo. How many people will be affected? Obviously, Tokyo suffer less number of casualties than Dhaka, and Dhaka will suffer a lot. So, what IPCC STREX proposed that not only look at the magnitude of the disaster, look at other dimensions, socioeconomic dimension. It is not only the shaking of the earth, the community itself, its coping capacity, its awareness, this is also very important. And how many people are exposed, this is also very. So let us try to understand South Asia in terms of flood. Now, in terms of H, that means the hazard itself, the flooding intensity. Its geographical location is at a very unsuitable location, and it is very much prone to intense flooding because precipitation occurs. It is in the windward side of Himalaya. 3 major river system has been developed there. Indus river system, Ganges river system, and Brahmaputra river system. So geographically, and because from Bay of Bengal for Arab Sea, the air flows toward Himalaya and then orographic rainfall. So this is the huge amount of precipitation. Asian monsoon, another important thing. I'll try to explain that this is a very unique phenomenon for Asia, the monsoon, and this part used to suffer from climate change and global effect. That will further aggravate our hazard intensity. Local impact like cloud out. The term cloud outburst has been repeatedly mentioned in different literature, that nowadays the cloud and the precipitation sounds like very intense for a short period of time. So there is also an important factor that these are some of the things I identified. Exposure. How many people are exposed? Well, South Asia, a very tiny part of the world, but it accommodated 1/4 of global population, around 2 billion people. Riverine civilization, we are still agrarian civilization, agriculture repeated, and we live very close to river. We live in places where we should not live. I mean, these are floodplains and the extension of the river. We should avoid those places. We should not live there, but we live there because population density is very high, and we are very much dependent on river because of agriculture purposes. We do not have any land zoning. People in the developed country, they divide that, okay, this is the river, do not stay here, stay in this zone, this part may be flooded. So this type of things actually our exposure aggravated our exposure condition. Our economy is an important factor. The entire South Asia is not very economically solvent. I mean, per capita demand. Complex river networks. This will also explain later. Poor implementation of low inadequate policy support. So these are some vulnerability factors that further aggravated our flooding conditions. And as you can see, that population even in India, Pakistan, that you can see that the highest population is along the Ganges River in India. Entire India, the population density is highest. Similarly, in the region of Pakistan, that I wanted to show in response to population actually. The same is other countries. This is the population density of Egypt, and people live only along the sides of the river. Entire Egypt is actually dry. And this is the socioeconomic condition, as I told you, that in India, the population is around 2 billion, population density is very high, growth rate is still very high. Per capita GDP is, we are ranked after 135. Well, Bhutan is an exception, but other than this, South Asia, in terms of, I avoided Nepal and Sri Lanka because these are not Himalayan rivers. They don't belong to Himalayan rivers. We are talking about Himalayan rivers and the region and the countries. HDA index also, we are not in good shape. 134 and 129 and above. So that factors actually aggravated our what you can say, that the disaster intensity too much. Now, recent floods, climate change has causes or not. Obviously, significant factor and other factors are there, but in terms of age, whether climate change or other causes any impact. Well, Asian monsoon. The South Asia and this part, we must have to understand what is Asian monsoon and why it occurs. Now, as you know, that Asian monsoon is a phenomenon caused by the temperature difference between Eurasian landmass and the surrounding oceans. You know that between summer and winter, the air flows. During summer, air flows from sea to land. During winter, air flows from land to sea. And this, when the difference is intense, if the landmass is huge, and Eurasia is the largest landmass, Australia, other than Australia, South America, North America, it's the largest landmass. There's a huge intense pressure difference between land and sea. So we have for a long time we have a very specific climatic pattern known as Asian monsoon, and it again divided into two parts. This part beyond Himalaya, and this part in the windward side of Himalaya. It is divided by Himalaya again. One monsoon, Asian monsoon, is felt along this part, the another felt along that part. And there are clear evidence in literature that climate change will further intensify the process and aggravate Asian monsoon. So I can expect that the situation, Asian monsoon, will be intensified under climate change, and flooding intensity may increase. Next is the river network and precipitation pattern. As I told you, that Asian monsoon push air toward Himalaya during summer, and it caused for orographic precipitation in the windward side, and this created three major river systems: Indus, Ganges and Brahmaputra. And Ganges and Brahmaputra, two in terms of discharge, two largest river in the world. And their combined flow and passes through Bangladesh is the second largest in the world. So this geographical setup is also a very important factor. And if Asian monsoon intensify, obviously the rivers will get more and more water. Glacier melt is another issue. This Himalaya Hindu Kush region is known as the third pole. It has third pole means North Pole, South Pole, and the Himalaya. Third pole. Huge reserve of ice. There are 54,000 glaciers in the border of Hindu Kush Himalayan regions. And you can see most of them has direction towards South Asia. Some of them toward China or on that direction. Most of them has direction. And this ultimately, and these glaciers are melting. I heard that from literature, I found that around 13,000 glaciers in Pakistan. Maybe I'm not sure. It's from literature. The Pakistani experts may know better. Global warming will melt them, and already there are evidence of glacial lake outburst. Glacial lake outburst. It might have double impact. One is the flood. Another is shortage of water, fresh water in the long run. Once the glaciers melt, the river will get less water after several years. And then, yeah, sorry, I have to finish.
You want to reach the time, so request to kindly, finish your discussion at the earliest.
Okay. At 10 minutes or 5 minutes?
I think that 2 to 3 minutes would be much more beneficial.
Okay. Then I can. Okay. I can understand. Okay. So ice is melting like this way, and as you can see that this is and positive feedback mechanism, it will further aggravate in the Himalayan region, and our flooding situation may aggravate further, because the ice used to reflect when it's melt. We say positive feedback because the warming will be further more warmer condition. It's called positive feedback mechanism. So in future the condition will further aggravate. El Nino, La Nino might have impact, and for the last 4 years there was La Nina conditions, and there is literature the La Nina years often associated with increased flooding, particularly in Australia, Southeast Asia, and Ganges. So this might have another is cloud outburst. I explained it several, and you might have seen in literature, and it has been explained nowadays, that normally in an orographic precipitation that occurs along the Himalayan range, the air comes pushed up because of geographical barrier, a cloud form precipitation occurs. But when there is a localized heating, let's say that the foothill of the mountain has been deforested, an urban area has been developed, so heating occurs. So there's, all because of global warming, there is a local low pressure created. This low pressure has a tendency to push air up, further up. So the cloud doesn't fall. Instead, it is being pushed by another localized heating or localized low pressure system, and it grows in size instead of falling. Grow in size, grow, but at one stage it must have to collapse. And when it collapses at a very high rate. That means 1 centimeter per hour at 10 hours, no flood. But 10 centimeter per hour in 1 hour, flood, because it's beyond the capacity of the carrying capacity of the river. This is what happening in Pakistan, Bangladesh, and India, and many other places. I myself and my colleagues summarize some figures of climate change scenario. These are still on SSP scenario, shared socioeconomic pathways 2, 4, 4.5, 8.5. We can see that there is a clear trend of changing precipitation, increasing precipitation in South Asia. this part will experience higher precipitation. That means bloom is higher. And we have processed some raw IPCC data through some instruction, and we can also see that South Asia will experience higher precipitation. And unfortunately, along the Himalaya, we have higher temperature changes. So I smell these things may occur as well. So I don't want to go through detail of this. These are the summary. I should say that in South Asian water management from regional cooperation is very important. Okay, I will finish this because the other part, this is a very big presentation. I'll finish it here. Seriously, lacking, we need cooperation among different countries. Bilateral joint river commission we have, but no basin-wide river commission. For example, India, Bangladesh, we have a joint river commission. Nepal, India has a joint river commission. India, Pakistan has a joint river commission. But the entire South Asian river system is unique and all are almost same. India, Bangladesh, Pakistan, Nepal, because this is the windward side of the Asian monsoon obstructed by Himalaya, and the mechanism is almost same. So we should have a regional cooperation as much as possible. At least we should have some warning system. The countries have hostility among each other, and for unknown reason, India doesn't want basin-wide. We are, for example, for the case of Ganges and Brahmaputra, we are actually expecting that Nepal, China join us, but unfortunately, they prefer to be. GCM output, giant circulation model, climate change output, and downscaling we can do together. I expect that a regional center for flood risk management will be established that will look into the technical issues, scientific issues regarding the South Asian flood, South Asian precipitation pattern, South Asian monsoon, cloud outburst, and all these things can be SMRC the Meteorological Research Center, it can be revived and isolated. So that's all about my presentation. I think this is how we can progress. I don't want to anyway, this is what I wanted to mean, that the Ganges River is extended over 3-4 countries. Brahmaputra is extended over another country, so we need regional cooperation. Thank you. Thank you so much.
Thank you very much. And for the sake of time, I would like that we will summarize all these 4 talks in the end, and we will also request for the questions in the end. May I request to Dr. Shabazz for the next speaker, please?
Okay, Professor, I may or may not be available because it's already 1 p.m. 1:10 p.m. No, sorry, AM in Canada. I am staying in Canada now in Edmonton. So please excuse me. I may not be able to be awakened. But if you have any question, obviously anybody can contact me or collaborate with me. I'll appreciate.
So, Dr. Siraj, if I may ask you one question.
Okay.
Like you mentioned at the last, probably you were not able to finish your presentation about the regional cooperation. So, if you find just given the transboundary nature of the climate impacts in Southeast Asia, how can regional institutional framework better facilitate like a real-time sharing or better industrial water management? Thank you.
So, what is the question actually? You liked it or how to strengthen it?
Yeah, how to strengthen the regional institutional framework for better data sharing?
How to? Sorry, I can't hear. How to?
So, how to strengthen
Oh,
regional?
strengthen. Oh, that's a very unfortunate thing. We want to strengthen, but unfortunately, there are hostility between countries and for different way. That's why I told in one case, let us start with some issues that has no harm. Let's say you don't want to share water of Ganges with Bangladesh or share of water of Indus with Pakistan, but we can share that the warning system, develop a warning system. We sometimes cannot even understand or cannot even get the precise data of whether a precipitation is occurring in the upstream of Bangladesh, in Assam, in Uttaranchal, or even China or Nepal. So we may start with some topic which has mm, which has no harm. Win-win situation. Both the country will be benefited. Like this way, we can start. Like let us develop a warning system in South Asia, flood warning system. That might be beneficial for all the. But unfortunately, some countries in the upstream they think that okay, we don't care what is going on in the downstream. So why should we help them? In terms of warning system, even though it has nothing to do. The only way, if you withdraw water from a river, the upstream country is benefited. But if you share data of precipitation, of temperature to downstream country, you have no loss. You are not losing anything. But the downstream country is being benefited. We can start with those things. We can analyze general circulation model output. So like this way, there should be a form of diplomacy, water diplomacy among the countries, that how to deal with it, because this is a serious issue. If in this river, if the flood isn't a serious issue, if we can predict it properly, if we can, yeah, okay, thank you.
And for the valuable insight that even if we have a political conflict, we should start small and
Yeah,
data should help both of the countries. So thank you for that. Thank you,
right,
Dr.
yeah.
So I would like to now invite our second speaker,
Mm.
Dato Dr. Nasir Khan from Malaysia. So his topic will be Malaysia's applied water governance and integrated water resource management, engineering sustainable ecosystem through policy, technology, and application. So I would also introduce Dr. Nasir Khan, that is a Malaysian water resource expert and former Director General of the National Water Research Institute of Malaysia under the Ministry of Energy Transition and Water Transformation. He played a key role in strengthening Malaysia's national water research and applied hydro-environmental modeling capabilities. His contribution include leading the development and application of national-scale flood and river modeling tools, enhancing integrated river basin management studies, and advancing water quality monitoring framework for Malaysian river system. He supported the refinement and operational use of hydrological and hydraulic modeling system for flood forecasting, scenario analysis, and climate change impact assessment. He also involved in the development of water institutes, research outputs, and technical innovation, including decision support system for water resource planning, river health, assessment methodologies, and climate resilience tool used by the government agency for planning and mitigation strategies. Under his leadership, Water Research Institute strengthened its role in producing applied research products such as flood hazard mapping, sediment, water quality assessment tools, and national water resource studies supporting policy formulation under the Ministry of Water Transport. So thank you. Floor is yours, Dr. Kisan Khan. Thank you.
Uh, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. To moderators, secretariats, honored guests, and participants. First of all, I would like to express my sincere appreciation to the organizer for inviting me to participate in this conference. I hope this presentation will provide useful insight into Malaysia's experience and encourage further discussion and collaboration among all the participants among OIC members. I think we are talking this IWRM since almost 30 years ago, while I'm a junior engineer. But the theory is very good. the theory talking of managing water in a holistic way by considering people, the environment, development together. But practically, it's quite difficult to handle on the ground. Uh, Only since last 10 years ago in Malaysia, we already going very serious in the application of IWM on the ground due to the rapid urbanization, population growth, increasing water demand, water pollution, frequent flood and drought, climate change impact, need to protect water resources for future generation. So, in terms of policies related to IWM, for information, last year we already developed water sector transformation 2040. It's a national roadmap to transform Malaysia water sector. It's talking more to the sustainable, resilient, technology-driven, and economic contributor to the country. This policy is very clear. You can get it easily from our ministry web, Ministry of Energy Transition and Water Transformation, or we call it as a Petra. You can get it from the web, and maybe you can review lah. You want to do any policy in your country, you can make it this policy as a reference, good reference. Is we launched last year. And now we are going very serious in Malaysia, application of IWRM. The aim is to balance development, environmental protection, and water security to ensure the water resources remain sustainable for present and future generation.
Sir, are you moving your slides?
Yeah. We are moving. Yes. So I think this one, most of you all are very clear regarding this integrated water resource management. Is an approach that promotes coordinated management of water, land-related resources to ensure sustainable, efficient use of people, economy, and environment. So once we detail out what we apply in Malaysia, we are going to the physical asset management. I think in the members countries also we have all kind of asset. For example, dam, water treatment plant, rivers, coastal area, sea. So all the asset we available, but we have to do some integrated modeling, whether physical modeling or computer modeling. We should have proper data and very quality data, and should be integrated, talking of sediment, talking of water quality, water quantity, flood mitigation, protection area. This kind of data is very important. So we have to gather the quality data under this computer modeling. This is the first level. So the next level, we have to go for the systemic governance, where we have to combine with the real-time AI and IoT network, where we're transforming manual auditing into predictive continuous ecosystem monitoring to enable instant enforcement. Then we are going to micro level vision, where we have to develop some latest water policy related to the current and future issues, where we have to develop high level political framework, including the international commitment, maybe the SDG, and funding mobilization. So with three level combination, we can achieve the IWRM ecosystem and more practical, and we can achieve within the milestone we set up. So in terms of in Malaysia, we have a state level policy integration of financial accountability. We have a 3-step. Step 1 is we call it as a strategic deployment. we are targeted phase installation of AI IoT station in high-risk zone. For example, like logging area, mining, quarrying, uh, replanting area, industry area, all the development area, we have proper information and link with the AI and IoT. And step two, we are going for continuous auditing, where this one we are connecting with the latest technology with the sensors, drone, CCTVs, to monitor all the activities on the ground and regulatory monitoring by the each agencies. And then we go for step three. We call it as a licensee-based governance model. Sometimes, these operators, they can't achieve the target set up by the agencies. So we're giving them chances, some allowance period to them to improve. For example, like industry, they have to improve their treatment plant, for example, so they can achieve the standard effluent. So that grace period, for example, 6 months, we are giving normally 6 months to improve their treatment plant. So that period they have to pay based on loading lah. We apply the TMDL concept, and they have to pay monthly bill to the relevant agency. Next. So at the same time, for the IWRM application or practical on the ground, we should develop technology, because we find out we cannot hope to the technology from Western or US, because from our experience, the Western and US technology is very expensive and the maintenance cost is very high. So that's why our government is encourage the local expert to develop local technology, develop manufacture local products, whatever related with water. Mr. Chairman, I would like to I have some urgent meeting. My senior researcher will continue this talk. I'm very sorry. He's a Dr. Nazri will continue my talk, and then you will any question whatever you can email direct to me.
Hello, Assalamualaikum, and hi everyone. I'm Dr. Nasri. So basically, these are a few, several Malaysia Water innovative products, and one of them is the Nahrim Invisible Levy System, and there are two types. The first one is more towards in the urban area. Okay, the second one is more towards the river system. Okay, the third one is the mobile flood wall barrier. Basically, we designed this for the individual residents. Okay, next is the. Okay, this one is we also have the Nahrim Autonomous Water Quality Sampling Drone, which is specialized for, we are going to take the water sample in rural areas or any location that cannot be accessible. So that's why we are going to go for the drones. And we also have the nucleus Nahrim Channel Stabilizer, and in order to protect the riverbank from the erosion. And we also have the NEEDS, Nahrim Environmental Dredging System. So basically in Malaysia River, it contains high suspended solids. So by having the NEEDS, we can filter all the suspended solid according to their sizes, types, and also according to different type of sediments. Okay. Then we also have the Nahrim Hydraulic Marker, also known as NHM. Basically, this installation of the NHM is we are going to explain or also to give to raise attention towards the nearby villages or people around that what is the reserve area for the river itself. And next we also have the Nahrim Oil and Food Waste Trap, no fat. Basically, we install it at the residential and also commercial outlet in order for us to treat the wastewater from all these residential areas from preventing the oil from entering the river system. And we also have the Nahrim Geoprotect, which is kind of the interlocking in order to prevent the erosion of the riverbank. Okay, so basically this is the idea. Okay, and also we have implemented this for the construction sites and also for the logging area, where we have the drones, CCTV, and also sensor, which all the information will be channeled to the control center. Okay, basically all the our innovation we are going to install in a one river basin. We call it as the smart river basin ecosystem. So this is the idea of our innovation. Okay. So way forward, the first one, we are hoping for the regional cooperation. So for example, like today, we try to share the knowledge and also the information that we have in all the among the OIC countries. We try to share the knowledge so that we can have a future discussion about the implementation of this application. Then we also have the second one is we hope for the technology investment, in which we can also go for the promotion of the desalination, recycling, and also smart irrigation system. Okay, so the technologies can be implemented, can be shared among the OIC countries. The third one is the integrated management. We hope for the balance in terms of the environmental, social, and also economic water needs. The fourth one is the awareness campaigns, which is one of the non-structural measures in order for us to educate the communities and how they are going to conserve the water, recycling, and also reduction of the waste or pollutants inside the water. So I think that this is the continuous process that can be done in all the OIC countries. So conclusion is the empowerment and the implementation of the IWRM across OIC members countries should be further strengthened to ensure sustainable adaptation and security water resource management. And for Malaysia, we remain committed and we want to collaborate and also share our expertise and support the realization of this aspiration, okay, for the benefit of all OIC countries. So basically for the further inquiries, you can also email and also contact directly with the Datuk IR Dr. Nasir Khan, or you can also contact me, okay, via my email. So basically this is the idea, okay, for all the river basins, in which before we can found that a lot of forest trees and the people also cannot accessible, they are not utilizing effectively along the river basin system. So the after the image, okay, after we promote all this kind of idea, we can see how well we can utilize the river bank, okay, for the purpose of the community and also economic. So this is one of the river in Malacca, in which we have already promote, in which we have the cruise, we also have the shop lots along the river, which can also be can promote tourism towards all other people to come to Malacca River. Okay, so that's all from me. Thank you very much. Is there any question that you want to ask? And you can also email to me. Okay.
Now, I would like to invite the participants if they have any question and they can ask the speaker.
If anyone has any question, please go ahead. I think that your presentation was, precise enough. There is no question from the audience here. And we thank you, and we would like that if you can stay back to the time, we have the other two talks also, delivered. In case there is any question arise from any of the participants, so that can be asked to you. Thank you, Mr. Nasiri, for your very valuable thoughts with regard to IWM approach in Malaysia, and the use of technology and the use of integrated management approach for a future sustainable, integrated and secure water regime in Malaysia. And finally, with regard to having similar sort of a cooperation at the level of OIC among the all OIC countries. So that is the undertake from your presentation. Now let's move to our talk number 3. And may the subject of the talk 3 is hazard assessment for climate change induced floods of 10 and 2022 in Pakistan. It is going to be delivered by Professor Dr. Shakil Ahmed. Uh, uh, Professor Dr. Shakil Ahmed is currently holding the position of professor at Department of Water Resource Engineering and Management, NUST Islamabad. His educational background includes MSc in Water Resource Engineering from UET Lahore and PhD from the University of Tokyo, Japan. And with over 25 years of extensive experience in consultancy, research, and teaching across multiple disciplines, Dr. Shakil specializes in studying the effects of climate change on water availability, hydrometeorological extremes, hydrological and hydraulic modeling, reservoir operation, and simulation for hydropower optimization and sedimentation. Through his career, he has contributed to various projects, some of which are Ghazi Baroda Hydropower Project, Gulpur Hydropower Project, Small Dams India Khan, Punjab Garages Rehabilitation Project, Recorded Water Resource and Management Study, National Water Policy and Improvements in Hydrological Modeling of Pata Water Resource Development Project. Moreover, during his academic journey, he has successfully mentored more than 35 postgraduate students and has published over 40 research articles in renowned international journals. Now, over to Dr. Shakil Saab for your talk on the speaker.
Good afternoon and Assalamu alaikum everyone. So I'm going to talk about the climate-induced flooding events in Pakistan in 2010 and 22. Okay, so here is the outline of my today's talk. So firstly, I would like to just brief about the basic understanding of the climate system that is really important, and then later I will talk about the flooding events. Okay, firstly, as we are well aware that as Allah subhanahu wa ta'ala says that we create everything from water. So that is what is really important, and it is very precious. So we need to take care while utilizing the water or wasting it without utilization. So that's why people live where there is a rain. As we can see, globally, green areas are showing the areas where we have huge rainfall, and that's why there is a reflection of the population density on same areas. Okay, so we are well familiar with that Earth system, which is really complex system. So we have so many feedbacks: land, atmosphere, water bodies, ocean versus atmosphere. Then we have number of gases in the atmosphere, which has also impacting all those feedbacks in the system. So that's why we need to understand those signs. Okay, so here is the global energy cycle. So which is actually triggered by, as we are well familiar that it is triggered by the solar radiation. So out of the 100 units, almost 47 units absorbed by the surface, either it is water body or continental area. So it has to be released back. Otherwise, the temperature of the surface will going to increase. So that's why there are three things: net long wave radiation and sensible, in addition to latent heat flux. So the net radiation and sensible and latent heat actually emitted back the absorbed radiation in the atmosphere. That's why during the night, so we feel better. Okay, so that energy cycle actually drives the hydrological cycle, and we can see the precipitation. Our ocean is more than less than the precipitation evaporation, while our the continental area, the precipitation is more than the evapotranspiration, and that compensation actually took place through the moisture advection from the ocean towards the continental area. And what drives that physical cycle? First of all, the solar radiation or the sun. Second is the gravitational effect. And third is, which is really important, that is the rotation of the earth, due to which there is a Coriolis force, due to which the winds are actually not blowing in the straight path. They have curvilinear paths all around over the globe. Okay, so regarding the atmospheric composition, so we are well familiar, in addition to nitrogen and oxygen, so we have other gases, carbon dioxide, which is very, you can so small, actually negligible as compared to nitrogen and oxygen, which is 78 and 21%. So carbon dioxide is less than 0.0001% in the atmosphere. However, it has an important role, playing an important role in triggering the climate change or global warming. Okay, so WMO statement says that out of 26 hottest years over the globe, the last 25 years actually were the hottest among those 26 hottest years uh, since the last century, right? So, due to which there is a IPCC assessment report 6, which is saying that almost more than 90% of the circulation models or global climate models saying that it is very likely that heavy precipitation events are going to increase with more intense rainfall. So that's why we are experiencing floods not only in Pakistan, all over the globe. So there is a very famous flood in Pakistan, and we are well familiar with that, but we don't know about its the mechanism actually that flood triggered, how it triggered. That was due to the Russian fire. That was not due to the, you can say, due to the local phenomena. That was the regional phenomena, and you can see due to Russian forest fire, there was a temperature anomaly over the uh, northern part of the park, right? Due to which there was a master flood, extreme or unprecedented master flood triggered northern area of Pakistan, due to which 2010 flood actually happened. And in 20, we have also experienced flood due to the torrential rain in the Balochistan region, as we can see in the lower left figure. So we can see if we the normal value of the rainfall. So we can see in Balochistan there was unprecedented rainfall as compared to the 30 years average rainfall over that particular region. Okay, so we carried out actually studies regarding the simulation of the hazards, which includes maximum depth, including velocity and the impact on the agriculture or cropland for both 22 event and 2010 event. And we used widely used hydrodynamic model, which is HECRAS, developed by US Corps of Engineers. So here are some glimpse of the flood inundation during 22 on different days. So we can see, however, I cannot show you the animation actually because of the last time available for the speaker. Anyways, so this is visualization of the maximum depth versus the velocity for those the maximum depth which are during 22 event. So this right figure is showing the NDVI difference, which is showing the extremely damaged cropland. So red area showing the areas where the cropland, actually that is the left side figure is showing the long-term average or reference cropped area. So we can show almost all the crops actually damaged over those region due to 22 flood. So this is again for 2010. So we calibrated that flooding event, and there was almost more than 80% matching of the flood extent versus the satellite data which was available during 2010. And we did same thing for the maximum depth versus velocity and the hazard assessment. And we already published that article in a reputed international journal. However, during 2010, so that is really important. So this most of the data is from NDMA. So more than 2 million hectares of land actually affected by 2010 flood, which is a huge loss of the crop area, right? Okay, so regarding those these floods, which actually triggered by unprecedented monsoon rainfalls, so which shows vulnerabilities in water governance framework in Pakistan, and the key challenges regarding water governances are as enlisted. First one is the inadequate institutional responsibilities which triggered weak coordination among all the government agencies and other agencies. Secondly, due to the poor implementation of the land use regulation. Thirdly, insufficient regarding the structural and non-structural measures. And the fourth one, which is not actually the last one, is the limited stakeholder participation in the water related decision making, right? However, the lesson learned during 2010 and 22 flooding events regarding the water governance is, as we know that floods are not actually only the hydrological events. So we have a lot of governance issues, so we can relate those events with the governance failures also, right? So that's why effective governance actually requires coordinated planning, transparency, and risk on decision making. However, these can be resilient, and that can be done through the integrated water resources management. And there are four pillars of the integrated water resources management. The first one is the integrated management of the resources. Second is the participation and inclusiveness of all the stakeholders. Thirdly, which is also important, is the sustainability regarding the environmental issues or other issues. And lastly, equity and risk sharing, which ensure fair distribution of the flood protection measures all around the region. And integrated water sources management practices include integrated flood management, watershed and catchment restoration, climate resilient water infrastructure, and we can also include early warning system. However, nowadays the term is being utilized no costing regarding the flood. So people are using artificial intelligence or AI tools while forecasting the no cost, which mean the forecast for next 5 to 10 minutes, not more than that, right? Which is no cost. So, however, these practices can be done through utilization of the advanced tools, and these are available free of. These are actually freeware, like ArcGIS, hydraulic models, including the CN Sport system. And however, in that case, that is really important real-time monitoring of the network regarding the floods and the precipitation. So, conclusively, the key message regarding the flood resilience through integrated water resources management is strengthening of water governance through integrated water resources management is essential for enhancing Pakistan flood resilience, climate adaptation, and sustainable water management. Okay, so this is last slide. So we need to be actually proactive rather than reactive. So as we can see a glimpse of one of the newspaper in 2010, I remember I took that figure from that newspaper, but I will not name the minister who was saying at that time that please pray for the prayers because the winter of 2010 was dry. Okay, so the winter of 2010 was dry. However, the praise worked very well, and there was a huge flood in 2010. And the minister is sitting on the rooftop and saying that good news is that the drought has broken, but underneath there is a flooding, even 2010. So which is very actually shameful for us. Okay, so the way forward is we need to be very proactive rather than reactive. So that we need to consider. So regarding that, in Japan, my professor done a wonderful study in I think 2007, where he done a study regarding the rainfall and by end of the century on the basis of the finest scale climate model. And Japan is working on the basis of that study. They already, I think they started their work for developing their infrastructure in addition to second, third defense line of the embankment in 2010. So there is a message from the advanced nation. So we have to actually work like that. That's all from my side. Thank you very much.
Thank you very much, Dr. Shakil Saab. Basically, you covered the 2010 and 2022 monsoon floods in Pakistan under the aspects of enter IWRM. And the final message probably is the most important, and that is how well we can now prefer that integrated flood risk management approach as compared to the preemptive flood approach and new technologies to be put in place. And above all, our water governance structure is deficient in many ways, both institutionally as well as on ground. And there is a dire need to put that into the right position. And in the end, I think that the message is little better fighting of our natural disasters, better IWRM approach can be adopted, and what better water conservation can be in the end achieved on ground, which ultimately is the purpose for Pakistan being the agrarian country. Now I invite if there is any question from the participants, kindly ask to the Dr. Saab.
Assalamualaikum everyone. This is Vanessa Gul. I am working in the water department, Muslims. So my question is, we all have known that Pakistan experienced devastating flood in 2010, 2022, and in 2021.
4 years.
So, what measures regarding government of Pakistan have been implemented in terms of mitigation and adaptation category since 2010? And what do you think, which measures have been successful and where there is still a gaps?
Which measures said? What I have understanding regarding especially Federal Flood Commission. So they have already working on the real-time monitoring of those flooding events. So that is one thing they are doing. In Pakistan Met Department, so they have improved their forecast model, but the model they are using, they are forecasting only 6-hour forecast, not the no cost, which has to be done. That is actually the non-structural measures. Regarding structural measures, I think Ahmed Kamal Saab can answer better than me because he was a chairman in Federal Flood Commission.
Let me, share couple of good practices that has been achieved. And number one, the Pakistan Met Department has been able to install two most important weather radars, one in Islamabad and one in Karachi. The Karachi weather radar now is going to take care of the Arabian Sea cyclonic activity, and by virtue of that, whatever devastation that we saw in the past can be averted. With regard to Islamabad weather radar, now that weather radar is going to cover the area from Peshawar to upstream of Multan. And earlier, the capacity of the Pakistan Met Department was for 24 to 48 hours forecasting. Now that has been increased to 7 days or so. So this yet another good thing that has happened. A National Flood Protection Plan has been formulated. R1 is being implemented. There is a good program being implemented in Punjab on gauging the water of hill torrents in the Kohen Suleiman area. A national master plan on flood telemetry prepared. Now a project on that is conceived, and it is going to be implemented probably this September or October for a period of 3 to 4 years. It involves 707 telemetry stations. Those stations will be put on different small streams, nalas, secondary and tertiary rivers, and the tributary rivers of Indus, Jhelum, Chenab, and all that. So by virtue of that, whatever flow that is generated by the floods, by the rainfall, that will be accounted for. And then by virtue of that, the forecast of the Met Department, the forecast of the flood of the Met Department will be further improved. Apart from that, some nature-based solutions have also been conceived, and those nature-based solutions relates to how well the surface water can be better utilized rather than wasting it. There is a good proposal on addressing the drainage issue in the province of Sindh. Why I'm saying that? Because the 2022 monsoon has seen much more drainage issue in Sindh because of the water, hill torrent water coming from Punjab and accumulating in the portion between Sakar and the Kotri Garage, and some water coming from the Balochistan. So there are good projects already there which are being implemented. Apart from that, over 500 automatic weather stations are being put in place by the Pakistan Met in the remote areas, so that real-time data can be taken from there, and then that can be fed into our forecasting models for better forecast. On the structural side, I should say that some good structures or flood protection works and spurs have been put in place in Punjab, especially, and in KP, and some projects are already in the pipeline for. So these are good things that are happening. But as Dr. Shakir has said, the main issue remains that the priority towards managing climate or managing flood is the least one. You can just imagine that from 2010 to 2022, in these 12 years, there was a requirement of about 110 to 120 billion rupees for flood management, and against that only less than 10 billion were spent, and that has resulted in that much of a devastation or damages on ground. So thank you very much for this very good question, and for the final talk, let me request Dr. Shahbaz Saab to take care of that.
Thank you, Dr. Shakil and Engineer and Kumar for the last. So now the last presentation for the talk of the session is titled Role of Smart Agriculture in Mitigating the Impacts of Climate Change by Dr. Shoaib Rashid. So let me introduce Dr. Shoaib to you all. So Dr. Shoaib is working as an assistant professor, Faculty of Agricultural Engineering and Technology, P. Meher Shah Arab Agriculture University, Rawalpindi. since 2022, and he's working as a director Center for Precision Agriculture. So Dr. Shoaib Salim completed his MSc in Precision Agriculture from Dalhousie University, Canada in 2012, and worked on the development of smart innovative technologies such as spot-specific sprayer and testing and evaluation of various variable rate technology in Atlantic Canada. His PhD work at the University of Glasgow was focused on integrated watershed modeling of southern Ontario watershed to evaluate the impact of future climate change and BMP on crop productivities and water resources. He also worked as hydrologist at the Ontario Ministry of Natural Resources and Forestry, and his work focused on wetland restoration to enhance carbon sequestration in the border areas of Canada and US in the Great Lakes region. As director of the Precision Agriculture Center, Dr. Salim's focus is on propagating precision and climate-smart agriculture technologies across Pakistan and worldwide. Many graduate and undergraduate students and researchers are working in his program, and he has developed several research labs in the Center for Precision Agriculture, named VRT Lab, Drone Lab, Mechatronics, and Robotics Lab. At the center, he is also working on establishing big data agriculture repository in Pakistan, and he has published several peer-reviewed scientific articles and presented his research work at regional, national, and international conferences. He has published a couple of book chapters on BRTs and environment in the latest book published in elsewhere on precision agriculture technology. The floor is yours, Dr. Chair.
Thank you very much for the introduction, and I want to apologize due to the sore throat. I might not be that much audible, but I will try to talk as loud as possible. So, as the co-chair mentioned, that the title of my talk is the role of smart agriculture technologies in mitigating the impacts of climate change, and as you know, agriculture is about the application of water, like from the surface water as well as the groundwater. And in terms of the integrated water resource management, often the component that is ignored in Pakistan is the groundwater. So that groundwater is being like the major source of source water for the agriculture production, and over 2 billion people worldwide rely on the groundwater to for their rural needs and irrigation and water resources needs. So when we talk about the agriculture, uh, what we are facing right now, it's a well-known fact that the population is being growing ever since, and we will reach about 10 billion people by 2050. And that means that we would need 50% of more food production and fiber for fulfill the need of our population, which needs about 100 million hectare of more area. So that much more water and that much more resources are required. And if we talk about specifically about the Pakistan, the urbanization and the shrinking of our edible land is putting more stress on our agriculture resources, and we need to produce more crop or more food for our growing population. Uh, but the negative impacts of agriculture, one of them is the GHGs emission, greenhouse gases emission, and it is estimated to be doubled by 2050 from the agriculture sector. So, what climate smart agriculture is about, that we will be talking today in much of my presentation will be about the how we can use the different precision and smart agriculture technologies to mitigate the impacts of climate change, and how we can adopt to some of the modern technologies to fulfill our water requirements and our fertilizer requirements, and at the same time increasing or maintaining our yields for our food production. So precision agriculture is a term that now most of our people like now they understood, but it's just to reiterate that the precision farm management means that use of smart technologies to ensure that the crop and soil receive exactly what they need for the optimum health and productivity in both spatial and temporal domains. So that means that we need to apply exactly what it's required. And in terms of Pakistan, we dearly need these technologies because we are about 70% of our economy relies on the agriculture sector, and we have the largest irrigation canal network, but due to the talks that were early presented, we are facing water shortages or the erratic rainfalls. So that means that there are opportunities as well. Our farmers are still relying on very traditional technologies for agricultural production. So if they adopt to these smart technologies that have been developed in the world, especially in the developed countries, about the precision site-specific nutrient management and the smart irrigation practices, along with the smart insecticide sprayers and weedicide sprayers and the harvesting technology, we can enhance our food production. At the same time, we will be able to manage our precious natural resources. So in terms of smart management, we from the sowing or land preparation to the harvest. So that includes the planting, that includes the irrigation practices, that includes the fertilizer and spraying management practices, and also the decision support systems to timely take the decision of on the agriculture on the different crops in the agriculture sector. So some of the technologies that have been implemented by water management department in Pakistan and also in different sectors is the high efficiency irrigation systems, mainly drip irrigation system. That there are multiple projects launched by the government of Punjab and Sindh on the drip irrigation enhancement. Unfortunately, due to the technicalities and the not the better education of the farmers, these technologies have not been propagated as much as they should have. But the government focus is still on the high efficiency irrigation system, especially that is the need of the next few decades, as we are facing the water shortages, especially in the critical crop growth stages. So we need to rely on these high efficiency irrigation systems. There have been now the government is also introducing at our center at the Center for Precision Agriculture is introducing the sprinkler irrigation system, which is also very good for the water management in terms of different cropping systems. So back in 2020, we launched a project called DDSTP, Data Driven Smart Decision Platform, for the purpose that was the PSTP funded project at the university, and under that project, this center was established. So the basic idea was to integrate the knowledge or the images of collected or the data collected from Sparkle, integrate it at the by use of the sensors and different field equipment, and perform the data analytics to take well-timed decision in terms of crop management, water requirement, and the water use for the cropping production. So these are some of the sub-components of this decision support system. And under that, we developed different dashboards. This is one of the initial view of the dashboard, that the sensors that have been installed are sending the information about the moisture content and different nutrients to our data center, and we send that information for the management of our farm. So that have played a critical role in terms of advocating that the smart technologies, along with the high efficiency irrigation systems, can not only save the water but also can optimize the crop production. So in terms of going to the regional scale, the agriculture and water, there are different changes in the hydrological processes, and that along with the anthropogenic activities have put in a lot of stress on the cropland, as I mentioned earlier about the water exploitation through the pumping. And some of the studies that I am going to quote now are from Canada about the climate change impacts on the water resources at the regional scale or the watershed scale. So some of the approaches that are being implemented worldwide are the index-based risk assessment tools, integrated water modeling for long-term prediction, and investigation of the extreme events. So I will present shortly about the results. So one first study was about developing a risk assessment tool, and that was through by colleague Nisha Prasad from to propose a methodology to assess the changes in agriculture and water quality due to the variability in future watershed condition. And for that, we selected a water shed at the Upper Park Hill, and the drastic model was used to actually assess the vulnerability index using the different climate change scenarios. And the scenarios that we were implementing, so precision agriculture or smart agriculture has another element of crop rotation, which means that we choose the crops that are more resilient to the climate change, and they require less water. So the three scenarios were developed: simple, which is existing or reference scenario, then the crop rotation scenario, and then the complex or resilient scenarios with the drains being put down in the area. So the overall results suggest that in terms of the resilience scenarios, they were significantly, if you can see that the red are the or red and purple stars mention the significant values for or significantly different values for these different 9 scenarios. But the red means that there is a shortage or there is more consumption of water compared to the purple, which means that there is significant less use of water. So that means that when we were putting the resilient crops or crops that are more that requires lesser water, so they were able to you know effectively utilize the water for the better crop production, or the yield was improved. So then the second study, which is my study, was basically about the investigating the nitrogen transport in water uh, using the different climate change scenarios. So I used the water quality models, the top water models like root zone water quality model, and then for groundwater or integrated watershed modeling, I used hydrogeosphere, and these scenarios were determined. So in Canada, this scenario is basically being implemented, which is the soybean crop rotation. So, but there's a trade-off between the production, because the corn is the cash crop and then the soybean is good for the soil health. The other was the continuous corn, and then the third scenario that was the introduction of wheat into the system, which is more water resilient crop. So the overall results suggested that the crop rotation or the BMP scenarios produced better economic returns compared to the continuous corn scenarios due to the effective utilization of the groundwater. So so this is the last component of my presentation, and I will briefly introduce the technologies that are being implemented at the Center for Precision Agriculture for the not only for better crop management, but for effective utilization of water as such at the farm level. Because we use sprayers. So this is the spot specific sprayer. The actual sprayer video can be visualized at our website. But that the concept is basically where the plant or tree is detected, we only spray at that part. So the testing at our farm and also at the farmer fields resulted in 40% of less water. That means that we were able to use it for the 2 times of the area. It's the same water that was required for the 1 acre. So the less carbon emission due to the less water filling and of the water supply tank. The second is the AI models that being implemented. So this is the spot specific sprayer for the field crops, and you can see that the different diseases or different plants are being detected in these models, and only those targeted areas are being sprayed. So we have been successfully able to develop these model and being implemented for different cropping system. We have developed it for groundnut, potato, and wheat cropping system, and we are working on the other crops as well. 2 more minutes. And then the auto steer technology, which is used for better or precise sowing. You can see that it's a driveless mechanism, depending on the GPS for a straight line sowing. So straight line sowing, if you are familiar with the water management, that means that the water can easily move through the field, and that requires lesser water compared uh, to the other water requires. This is the last one, the aerial spraying. That is also part of our precision agriculture program at the Center for Precision Agriculture, to actually spray the crops in a non-destructive way and use of very less water, about the 10 times less water than the field sprayers, to effectively target the weeds and also the different diseases in the crops. So these are some of the technologies. Detail can be visited later, like in terms of our on our website, or you can visit our center at any time. So the some of the UN SDGs and the way forward. So I did to conclude my talk. So we, as an agriculture country, we are relying on our main rivers and main water resources, but we need to focus more on integrated water resource management, taking accounts of our groundwater resources and how we can effectively utilize these resources for continuous agriculture production. And the precision agriculture technologies is one of these technologies that can help the farmers or our national economy to not only produce the crops for our growing population, but also at the same time save our natural resources. So with that, I would end my talk, and this is the website for our center and also my email for any further inquiries. And lastly, I would like to thank OIC and COMSTECH and the Turkish government for organizing this workshop, and for all of you for your presence. Thank you.
Thank you for demonstrating all the new technologies we are working on. And agriculture in Pakistan and many parts of the world consume more water than any other sector, and smart agriculture is the way to go. So thank you for the presentation. So any participants?
Yes, sir.
Question, please.
Talk about groundwater.
Yes.
You say you need groundwater in Pakistan is rapidly depleting,
Yes, sir.
and the population is growing, deforestation or whatever.
Yes, sir.
People are making colonies in floodplains, etc. So what legislation would you need to stop that so that your policies of better cropping can take place? Because there are so many factors involved in it.
So right now there is no practical legislation. There is a policy, or in terms of the documents, there might be something, but not a practical implementation. Government is providing solar tubes. That is, in my point of view, if it is not being monitored properly, is a disaster for our groundwater table, because that is being continuously pumping the water. Previously, people were paying for the electricity, but now with the solar, it's been continuous in operation, and that is depleting the water in our most fertile land like Jung and like these regions. So we need to develop, like I can give the example. I worked in the Ontario Ministry of Natural Resources there. So we had the water accounting part where each farmer had its own share of water. So how much he can pump, and all the pumps had the water meters on them. So they were continuously monitoring how much water being pumped by each farmer. And so that is one of the way to go to actually put a limit on the exploitation of the groundwater. And that can keep up. And then the recharge wells, which is now somehow like is being the talk in different sectors, but recharge wells. And also, like we've been in, especially in the during the urbanization phase, we didn't realize that some of these natural wetlands were actually filled, and they were now being used for agriculture or urbanization purpose. So the natural recharge mechanism, which are the lungs of the earth, have been already filled with the concrete or with the soil. So we need to take concrete steps in developing this integrated system where we are not only focusing on our surface water resources, which is visible. Somehow they just focus on the visible, but the invisible, which is more important for our economy and agriculture.
Your aquifer.
Yes, sir. Groundwater.
Yes, exactly. And with the more water intensive crops, so it won't be 5 minutes. Rice and sugarcane, that also takes a.
Yeah, so that was the focus of my, like two regional studies, that crop rotation must be implemented at a regional scale. So there should be some incentive, if not some check. Like so farmers, they can, like they can follow some of the policies. If not 100% are following, if we can say that 100% are following, but if we provide them enough subsidies or enough incentives, they can switch to better crop water resilient crops.
Oh, well, thank you for the question. So, as you were answering the question, so you mentioned Canada.
Yeah.
And you said that they monitor their meter pumps and that they monitor. So, as far as little bit, if I can add to that. So, this kind of a system works when the number of farmers are little less because the monitoring costs increases as the number of pumps or the meters increase. So in Pakistan, there are small farmers, the land is small, the number of farmers are in thousands. So would you have any suggestion, or if you learned something there, how would we monitor thousands of small farmers who have maybe 1 acre, 2 acre of the land? And if you install meter, who will monitor? And is it the technology advanced enough so we can do that from the center, or we need some sort of?
Yeah, so not all farmers have the groundwater wells, but there are about 300,000 tube wells, and which can easily be monitored. If WAPDA is monitoring everyone for the electricity use, they can use the monitor the wells. It won't cost much, but it can be for the long-term planning. You need to actually see how we can monitor our precious resources, because this is somehow is gonna be the resources for our future generation.
So there's another question.
I just want to add, Dr. Saab's comments about the keywords monitoring for monitoring. Over in the Canada, actually, the purpose of that, they actually monitoring the not only the flow, they monitor the profile. If you want to install the keyword, so they want to say, okay, we want to go for the first assessment of how many you want to install over there, what is the drawdown over there, how much the water they extract from that keywords. This is a procedure, actually, there is a protocol to approve for the keyword, and also they are use that data for the water quality. That is there is any effect on the water quality on that one. So not particularly for the farmers, actually, they have the overall, they have a monitoring, they are all optimized system. Specifically in agriculture, in urbanization. That's the main purpose of it. You need approval, you want to work Fuel approval.
Permit to take water, PTTW, permit to take water.
And
Yeah, you need
they have
that. Yeah.
a procedure protocol and go through that.
Thank you.
जी शुक्रिया, thank you very much, Dr. Nabi साहब आपके intervention का, and this brings us to the closure of this session 3, which basically was on hydrometeorology and climate change. We had 4 talks given. The outcome of first talk was basically we need to have a better regional cooperation, especially for the sake of early warning systems among the regional countries. For the Indus, for the Ganges, and for the HKH region. For talk number 2, basically it was with regard to integrated modeling of sediment water quality and few technologies. The speaker from Malaysia, he talked about how they have conceived for the future transformation of their water resources under the realm of IWRM, and for that they have developed a vision 2040. And he also spoke about broader future cooperation at the OIC level to ensure sustainable and adaptive water security for all. For the third speaker, Dr. Shakir Saab, basically analyzing the 2010 and 2022 floods in Pakistan, talked about the failure of the governance or the gaps in the governance system and how well that can be taken care of by utilizing the flood water or otherwise the available water for the better use by employing better governance strategies, better technologies. For the fourth speaker, he basically had his input on how well smart technologies and the precision technologies can be used for less water with more agriculture output. I think that all these 4 talks have brought us to one conclusion that water is a precious commodity. It is by virtue of the Dublin principle is it is not an infinite commodity, it is a finite commodity, so we need to conserve it, and for that very reason we need to have a much more better enhanced cooperation among the OIC countries. In the end, I would like to thank all who participated, my co-chair, Dr. Shahbaz Saab, all the participants, the OIC COMSTECH Secretariat here in Islamabad, and the Turkish Institute of Water for organizing this and for giving me this opportunity to be a part of this discussion and also to upgrade myself with regard to whatever the new things that are coming up in this sector. Thank you all once again.
I would like to extend my sincere thanks to Chair Dr. Ahmed Kamal and Co-Chair Dr. Shehbaz Altaf and all distinguished speakers. So now we have a lunch and prayer break till 2 p.m. So we have lunch is served and inshallah after that sessions for Miss Nasli, are you here? Miss Nasli? And Dr. Tubba, Ibrahim. Hello, Miss Tubba, are you here? Okay.
Yes, I'm here.
So, Ms. Tubba, due to shortage of time, we will limit our presentations to fewer minutes, like 25 to 30 minutes of this session.
Okay. Mine is to 40 minutes. Okay, I will make it shorter. Okay.
So it's also a request from Miss Nazli as well.
Okay. I think she's here. Yeah.
So officially, we are going to start this session.
With Miss Nazlı presentation, as I know.
Yes, yes, I think my presentation is the first one.
Yes. Yeah. And Mr. also the chair of the, I think he will be there also.
I'm
Mr.
inviting.
Engineer Said Ayas.
Yes, yes, yes.
Okay.
So for the session number 4, water management in diplomacy, our chair for this session, Engineer
Okay.
Sayyid Muhammad Haider. Sir,
Okay.
thank you. And our co-chair is Dr. Tubba Evrim from Turkish
Yes.
Water SUN. So I respectfully invite both of you to lead us through this important session and share your valuable expertise with the participants throughout the session and to moderate the session. So our first speaker is Ms. Nazli from Turkey.
Thank you. Should I start or are we waiting for a few more minutes?
Yes, you can start, Ms. Nazli.
Okay, I will share my screen. Okay, is it in presentation mode in your screen as well at the moment? Okay, thank you. Thank you again for all of the participants today. I will briefly explain Turkey's water efficiency strategies and applications. I will try to keep it short and brief. So thank you again. I'm an environmental engineer at General Directorate of Water Management in Turkey under Ministry of Agriculture and Forestry. So I will explain water efficiency within the framework of adaptation action to the climate change. So sorry. So when we look at the recent trends regarding climate change, we see that we experienced the warmest 10 years for the last 10 years, and we experienced more floods and droughts within the last 50 years. And as I mentioned before, we experience more frequent and prolonged droughts. So in this figure, when we look at the global drought outlook, we see that over the previous 20 years, we experience more droughts more frequently, as well as in some regions we experience droughts more intensely. So, and when we look at the extreme droughts, especially, we see that in some of the regions in the world, droughts has become more severe. So, Mediterranean Basin is one of these regions. In the sixth assessment report of IPCC, the cross-chapter paper 4, Mediterranean Basin is recorded as one of the most vulnerable regions. So what are the key risks? Water quality and availability is one of the factors that would be affected the most due to the global mean temperature change with a high confidence level. If we don't we don't implement transformative adaptation action. So when we look at the Turkey's situation, we see that we are currently experiencing water stress as 2025 data show us. But the situation could be worse in near future. as population increases and our water resources will become more scarce. So we need to take some kind of precautions. We need to get into action. So here comes the water efficiency. We need water efficiency to deal with the negative impacts of climate change, population growth, urbanization, extreme consumption patterns, and increasing demand. So we need to balance our demand and supply, balance our resources and our demands. So how do we define water efficiency? We define water efficiency as minimization of the amount of water used to accomplish a function, task, or a result. So within the scope of this, in Turkey's first nationally determined contribution, we have some policies regarding adaptation action of our water resources. So establishment of water efficiency in building and providing incentives for the use of grey water and rainwater is one of the actions. Preparation of sectoral water allocation plans, adopting resource efficiency principles in all sectors, rehabilitation and modernization of irrigation systems, increasing our rate for treated wastewater reuse to a certain ratio, and to reduce our water losses in drinking water supply and distribution system networks is an important policy, are important policies regarding adaptation action. And all of these policies, which are included in our first national determined contribution, showed us that Turkey needs a comprehensive water efficiency strategy. So for this purpose, we have started water efficiency initiative under the auspices of First Lady Emine Erdoğan. And following this, launching this initiative, we have published national strategy regarding water efficiency. And this strategy has 4 different components regarding different sectors, most water intensive sectors like urban water use, agricultural use, industrial sectors. And this strategy also involves some horizontal components regarding all sectors, cross-cutting components. So all of these strategies actually constitute the second nationally determined contribution of Turkey, which was recently published, recently declared. And within the scope of this contribution, national determined contribution, second NDC, National Adaptation Plan is one of the main actions that is going through at the moment. And water sector has funded on this water efficiency strategy mainly. So in this strategy, first of all, we have determined our national targets for different sectors regarding the current situation as well. So we currently in 2025 data, we have recorded that Turkey has average of water loss data of 31.6% nationally. And we have agricultural irrigation efficiency rate of 52%. And we have household water use efficiency as 154 liters per capita per day. This is our current situation, and we don't have reliable data that we could show for the industrial water use rate, water recovery rate at the moment. But so here, based on this current situation data, we have determined our targets for each sectors for 2030 and 2050. So we need to reduce our losses in all sectors, and we need to constitute more productive, more efficient systems in all agriculture, industry, and municipal in local governments as well. So I will briefly explain each sector, what are we doing at the moment. So when I start with urban water efficiency, we have 3 main subtitles under urban water efficiency targets. So here our main goal is to improve urban water efficiency through reduction of leakage and losses in water supply networks, through improve our water efficiency in one of the most intensive water intensive sectors, service sector as tourism, and to reduce our household water use. So what are we doing for this purpose? So first of all, we are claiming that we need to adopt from source to tap approach in our local area, in our urban areas. So what does this mean? What does from source to tap approach mean? So we need to adopt efficiency practices at each component of our water distribution network, from abstraction of the water from its source. It continues in the distribution, in water transmission network, in water distribution networks in our cities, and it also continues in consumption patterns of the individuals through reducing our, through changing our equipments, through changing our behaviors as well. And then it's not only about the efficiency of the fresh water, but it's also important what we do afterwards, after using this water, after creating the wastewater. So we need to adopt some actions regarding the reuse. So here comes the non-conventional water resources in urban water efficiency practices. So by non-conventional water resources, we mean used water reuse, rainwater harvesting, grey water, and I will explain them in more detail in upcoming slides. And also, we have some horizontal components in urban water efficiency from source to tap approach as well. So here comes full cost water pricing, incentive water pricing, in other words, public awareness campaigns, which would cause the change in behavior, water consumption behaviors, and also nature-based solutions is an important component in this act. So by nature-based solutions, xeriscaping techniques and smart city model are some important applications. So I talked about xeriscaping. So what is xeriscaping? Xeriscaping is defined as drought-tolerant landscaping techniques, and we are actually currently promoting these techniques in nationally. So what are the fundamental principles? So here we define the fundamental principles. We could list fundamental principles as adoption of as dissemination of the use of vegetation with respect to according to according to the local climatic conditions, and native vegetations should be selected. And also, not only drought tolerance is important, but tolerant vegetation to the salinity is also important, is also main principles in xeriscaping techniques. Then we need to adopt efficient irrigation methods in landscape areas. Also monitoring how much water we use in landscape areas, monitoring this is also important, because we don't know what kind of action we need to take if we don't know how much we consume. So then we need to also conduct soil analysis. We need to make irrigation regarding the properties of the soil, mineral contents, other chemical contents, and so on and so forth. And also adoption of non-conventional water resources comes to the front in xeriscaping techniques in principles as well. So through adopting these principles, through adopting these techniques, we found out that we could obtain up to 50%, average of 50% water savings through xeriscaping, and we could decrease our maintenance and energy costs up to 50% as well. So I mentioned about change in human behavior, public awareness campaigns, and for this purpose, we have conducted, we have prepared training materials, and we have started from children. As you know, raising awareness starting from a young age is very important and is very impactful, in fact. So we have conducted education trainings nationally in all provinces in Turkey, in all cities. And we have reached up to 2.9 million students up to now, and we are conducting these trainings for each level of children, like early childhood, primary school children, primary school students, middle and high school students, and so on. So moving forward with agriculture sector. So similar to the global pattern, Turkey is currently has 77%. Turkey's current water consumption, 77% of Turkey's water consumption is for agricultural irrigation. So it's a huge amount. So we need to take immediate action. We need to take a huge action in this manner. So what are some strategies, what are some practices that we are adopting in our agricultural irrigation lands? So we are promoting modern irrigation systems. We are making planning based off water availability, crop pattern planning based off water availability. We are adopting monitoring and measuring systems in irrigated lands. Non-conventional water resources is also an important component here. Raising awareness among farmers or other stakeholders is also important. Because without knowing how to apply efficiency actions, it would be meaningful. One of the most common examples is that you have drip irrigation, which is the most efficient one. But if you keep it open for a very long time, it's not efficient anymore. So you are wasting your technology and your money at that moment. So our Ministry of Agriculture and Forestry also provides 50% of grants for farmers which are using pressurized irrigation in their lands. So moving forward with industrial sector, so we have conducted a study in our country, in Turkey, and we found that food, textile, metallics, and chemicals are the most water-intensive industrial sectors. They are the main water users. Approximately 65% of total industrial water use is caused by these sectors. So, but they are different sectors. They have different processes, different raw materials, different water quality requirements. So we need sector-specific measures in industry. So we cannot come up with some generic measures, generic practices. We need to act upon sector-specific. Right. So we have analyzed best available techniques of European Union, and we have come up with our best available techniques as well, which are currently adopted in Turkey. And we have produced sectoral guidelines for each different types of NACE codes. So this is an important study. This is one of the most comprehensive studies in among Europe, actually, within the context of water efficiency, I mean. So we have come with different types of water efficiency practices, from management to technology change to reuse applications for food sectors, for textile, and so on and so forth. And these are publicly available documents, actually. So I have mentioned before that we also have strategies for horizontal components. As you have recognized from this presentation, I have mentioned reuse of used water or rainwater harvesting applications in different sectors as well, like urban water efficiency and agricultural water efficiency. So we have strategies about these non-conventional water use as components as well. So when we looked at the gray water use, we have found out that approximately 80% of our domestic water use is actually constitutes gray water. So by reusing this gray water, we could decrease our water supply per household by 50%, up to 50%. And when we look at rainwater harvesting techniques, we see that we could achieve 60 decrease in water supply per household by 46% through rainwater harvesting applications in our households. And when we look at reuse of used water, we have determined our potential in terms of both reusable wastewater and also agricultural drainage water reuse. And we found out that we could reuse 44% of our wastewater and 66% of our agricultural wastewater, agricultural drainage water. And we could reuse this water in different areas, like we could store this water in water storage, we could use that in agricultural irrigation, as I mentioned before, and landscape irrigation as well. And also an important reuse area could be recorded as environmental flow requirements when needed. And also industry is another important area that we could reuse our wastewaters. So I have mentioned about practices, I have mentioned strategies, and for this purpose, in implementation, we need a legislative framework regarding water efficiency. So we have developed, we have integrated all these approaches in our policy instruments as well. So we have established a National Water Board, which which discusses water policies in a high-level perspective and comes up with umbrella strategies which would be relevant for national politics. And we have prepared our draft water law, which is not actually at the moment not enforced, but we are working on that. And one of the most important outcomes is that water efficiency regulation is enforced in 2024, at the end of 2024. And this regulation actually brings water efficiency systems in all sectors, establishment of water efficiency systems. By water efficiency system, I mean more like a management system, managing our water in our units, like in public institutions, in irrigation facilities, in industrial facilities, and so on and so forth, in local governments as well. And how can we identify whether there is a system or not? So we have come up with a certification system as well. So whether an institution or a local government or an irrigation facility, if you establish a water efficiency system, you need to certify it. So this certification brings standards regarding water efficiency practices. So another component within this regulation is provincial water efficiency plans. So in this scope, we are trying to establish the current situation assessment in all provinces, in all cities of Turkey. And then we need to define city-specific targets for each sector. Because each city has different geographical conditions, different rainfall data, different, different demand, and so on and so forth. So we need to establish a geographically specific approach. So how do we integrate all these data, all this system? How do we, as decision makers, how do we use this knowledge? So we have established water efficiency information system. This is not currently publicly available, but it will be launched in a short period of time in near future. We hope so. So we are coming at the end in this information systems establishment. And so water efficiency regulation actually brings us a more systematic approach in water resources management. So in conclusion, as I mentioned before, climate change is turning water scarcity in a structural challenge. So Turkey is one of the most vulnerable countries as it is located in Mediterranean region. It is exposed to key risks. The region is exposed as well. So water efficiency reduces vulnerability to droughts and also not only droughts, but also other imbalances caused by supply-demand inequalities or imbalances. And it enhances climate adaptation capacity, water efficiency practices, I mean. And also, it supports sustainable development goals, as water is central, water is in the intersection of the global development. So national water efficiency strategy, our national water efficiency strategy actually operationalizes climate commitments through its contribution to our nationally determined contribution, and also our national adaptation plan, and it also provides a cost-effective and scalable response. So we are not actually giving up our needs, but we are just optimizing. We are using technology to do that. And efficient water use is currently central to our country's, Turkey's climate resilient future, and it's highly important. Thank you for your attention. If you have any questions, I could answer them.
Questions?
If anybody has a question.
Online participants also?
So the chat box, but there is no question. So no question. Yes. Sir, आप बोलेंगे?
The next speaker है?
जी sir.
Oh, this one.
Thank you, Ms. Nazli, for your brief
Thank you.
presentation and for the insightful remarks. So next speaker is Mr. Mustafa Soleh Sarikaya from Turkish Water Institute SUN, and his title of is talk is benchmarking of the performance of water utilities. So Mr. Mustafa.
Yes, I'm here. Can you hear me?
Yes. Yes.
And
we
see
can.
my slides.
Yes.
Okay, good afternoon and good morning to the brothers and sisters in COMSTECH and all around the OIC world. It's my pleasure to present the concept of benchmarking as a concept that's applied to monitor the performance of the water and wastewater utilities. And it has become a powerful governance tool in the water sector worldwide. And as you know, water utilities face increasing challenges with regard to climate change, urbanization, population growth, aging infrastructure, and financial constraints, as well as the rising expectations from the customers. So we need a systematic.
Sir,
Can you hear me?
Slides on the slideshow?
Sorry?
Can you please put your slides on the slideshow mode?
Full screen'e geçebilir misin?
Full screen.
Şimdi gözüküyor mu?
Notlarınla gözüküyor. Öteki
Ha.
ekranı seçmen gerekiyor.
Şöyle yapalım. Oldu mu öyle? Şimdi oldu galiba. Is it right now?
Yes, sir, it's fine.
Okay, so my hope is to demonstrate the concept and the use of benchmark. I assume I have a limited time, so I'll try to keep it short. So the structure of my presentation will be based on definition, importance, and types of benchmarking. I will show some examples nationally, internationally, and regionally. And we will focus on SWAN's benchmarking study applied since the year 2015. And I will also reflect upon our success factors based on our experiences, and I will try to give some recommendations to be applied in other countries. So the world benchmarking is originating from the word actually benchmark, which is used by field surveyors as a reference point. And also the shoemakers in the past, in the history, use the word benchmarking. So a shoemaker, a master, puts for his apprentice as an example, a reference shoe on the bench to be taken as an example. So basically, benchmarking can be defined as a process of understanding, evaluating the current position of a business and organization in relation to the best practices. So simply, we could define it as improving ourselves by learning from others. So it is quite an important tool, as I told, applied in the water and wastewater sector. The issue we have in the water and wastewater sector, and it doesn't face any market competition, so it has a monopolistic characteristic. So there is no external pressure from the customers or from other stakeholders exactly for the water utilities to improve their performances. So benchmarking can come into play to improve and fill that gap. And it is worldwide applied, as I told, in different countries. So basically the steps here starts with planning, analysis, integration, action, and it turns into maturity. So it should be somehow integrated into the routine operations of the wastewater and wastewater utilities. So the benefits of benchmarking are numerous. It is motivating the operators to improve their efficiencies. It serves as a constant element of pressure, as I told, to improve their service qualities to the citizens, to their customers. It enhances data transparency and sharing, and also allows a platform for knowledge sharing between among the utilities. And we could classify benchmarking into two aspects. So it could be internally done, and it could also be external. So some organizations benchmark their internal units. Well, mostly done, it can be used as an external benchmarking exercise. So that's actually the most common form. Utilities benchmark themselves against other external utilities. So another classification could be based on metric and process benchmarking. And again, the most common form here is metric benchmarking. So we focus on performance indicators, which are quantitative. On the other hand, process benchmarking focus on the processes. So one focus on the quantity side, the other focus on the process side. And it is also equally important to explain what benchmarking is not. It is not a one-time effort. It is not just copying others, and it doesn't serve as a quick exercise with simple answers. So it requires quite effort, and it's a time-consuming and it requires, as I told, an effort-based study, like we did, which I will explain later. Benchmarking is widely used in the water sector. First, Harvard actually raised the use and applicability of benchmarking as a tool in the water sector. Then the Dutch used the concept in their water sector. And since 1996, especially in Netherlands, especially, the water operators use benchmarking quite extensively and mostly on a voluntary basis. And water and wastewater services can be delivered in different formats, but mostly in OIC countries as well as in Turkey. The water services are delivered by public organizations, but there can be mixed solutions and options in which water and wastewater services are given separately or in a combined manner. It could be given by public and private institutions. For example, in France, the water services are given by two separate private companies, while the wastewater services are provided by public organizations. In Turkey, we have the water and sewage administration. The previous speakers explained a bit about their status, but we have 81 cities, provinces, and 30 provinces are metropolitan, have metropolitan status. And in these 30 provinces, there are 30 water and sewage administrations that operates in a semi-autonomous manner under the metropolitan municipality. So they are under the municipality. And I think it's important to state that they serve to about 80% of the total country population. So they have a very critical role in delivering the drinking water to the urban customers. So I would like to also give some examples, international, regional, national practices in benchmarking in the water sector. The very first one would be the International Water Association. I assume most of us and you know about this association. It has a critical role in benchmarking. They have formed in 2010 a specialist group in benchmarking and performance assessment, and they have prepared and published a guide, a quite extensive guide on good practice on benchmarking and how to use it, and they have given a detailed list on the performance indicators and indexes to be evaluated and to be applied in relevant countries. So they have basically 3 steps, which consists of preparation, performance assessment, and performance improvement. And I think the most important part here is the data acquisition and being able to validate that. So based on our experience, this is the most time-consuming aspect and component of the overall process. So we need to have really good quality data acquired from the water and wastewater utilities. And another good initiative that contributes to this concept is the IBNet program that is set up by the World Bank. It is the International Benchmarking Network for Water and Sanitation Utilities. And it started as a financial evaluation tool, but it has extended to include other aspects, technical aspects, water distribution, sanitation coverage, and non-revenue and other technical and operational indicators have been incorporated into this tool, and it has the largest global database, including around 3,000 utilities from over 150 countries. And in Turkey, we also some utilities are part of this network internationally. So they focus on 15 performance indicators, from water operations to sanitation operations, as well as human resources and financial management aspects are here part of the assessment. They have refined the number of the indicators. They used to have more, but they have adopted the philosophy of less is more. So they have now refined and reduced the total number of performance indicators to 15 in total. And they also provide good practices to see the underlying factors, to explain why a utility is underperforming or overperforming. So they have defined 7 categories. So each utility, especially those who overperform in relevant indicators, provide management practices. So the other ones could see how they achieved that performance. And they have come up with an index called UPGAR index, which is a composite index that includes the most fundamental performance indicators, water coverage, sewage coverage, water loss, and so on, and as well as affordability. So they have a reference scale for each reference values for each performance indicator, and eventually there is a score calculated for each utility. So it could be having a critically low performing status, while it could be above normal performance status. So this is a important scorecard index that is widely used by the utilities. And there are other practices, regional practices. The American Water Works Association, again, is a voluntary-based initiative that includes more than 300 water and wastewater utilities in the United States from 35 states in this study, and they have classified and clustered the performance indicators into 5 main performance areas, as you can see on the slide. And another one is the European Benchmarking Corporation, which similarly is done on a voluntary basis, and they have 5, again, performance areas defined which is mostly in line, with the other initiatives. And when it comes to national practices, we see the Dutch. They have applied benchmarking since 1997, and they have reported to have productivity increases up to 41% for the period of 97 and 2012. I don't know how they calculate, but this is has been reported by the government, and they have, as you see, 4 main areas with underlying indicators. And Canada also applies again as a voluntary non-regulated exercise on 7 high-level performance goals that are defined by the Canadian authorities. And Ofwat, as you know, the British apply and has set up a water services regulation authority under the name of Ofwat, and they have done benchmarking studies, not voluntary, but it is obligatory to be done by the utilities that are private mostly. And the Danish and the German also apply sector-wide benchmarking studies. So these were the international regional experiences and practices, examples that I would like to share. But now I would like to focus on our own study in Turkey that covers the 30 water and sewage administrations. We could call it as WASAs. And since 2015, we periodically perform these studies, and we have so far completed 3 phases and 3 outcome reports, and now we are about to finish in the coming months the 4th phase that covers 29 WASAs out of 30 WASAs. And this study was featured on OECD's handbook on solutions for the local implementation of the OECD principles on water governance. As my colleague Ms. Elif explained, this was highlighted and featured under the pillar efficiency and data information, as well as on monitoring and evaluation as a good practice done nationwide. And here you can see the steps. It is, as I told, a quite long process. It takes about 1.5 years. And we all start with the review of literature, and we determine the variables, and then based on the variables, we calculate the performance indicators and indexes. And then, of course, based on the data collected and acquired, and as well as validated, and we share the outcomes with the relevant stakeholders, mostly utilities, indeed. And this is a pyramid I would like to share that shows the transition of the very raw data that we acquire, and then we turn those into validated and analyzed data, which eventually are converted into indicators and indexes. And we have set up a database and application software. It is not necessary to do this, but I think it's quite valuable to institutionalize the study, but it could be done just on a MS Excel base, but I would not recommend that. Again, to collect it on a more institutionalized format would be more effective. And again, I will share. I will not go into details, but we have quite many variables, and the primary data that we collect from the utilities, and it is about 190 variables that we collect and validate and analyze. And these are turned into performance indicators afterwards based on the performance areas that we have defined. So it is, again, similar to the other initiatives. It includes drinking water, wastewater, environmental aspects, as well as energy efficiency and so on. So 180 performance indicators are reported back to the utilities and other authorities. So these are some examples of the performance indicators. For example, it could be related to human resources, the staff per 1,000 customers. As you can see, it has a quite variation among the utilities. So the portion of the utilities that have a massive gun or the water loss analysis. So you can see we break down all components of the water loss, and we correlate the results with the other performance indicators. So to see and observe what kind of correlation exists between relevant indicators. And then this is another example for wastewater reuse. And we also benchmark the national results with international good cases and good performing countries. And we produce a dashboard that could be, of course, produced in different formats, but these are the fundamental ones that we report again to the utilities and other relevant authorities. So again, these are not up to date, so we hope to update these this year with the data of 2024. And as I told, we have used performance indexes to customize IBNet UPCAR index. So we customize the IBNet UPCAR index to the local conditions, and we also have developed another performance areas index to comparatively demonstrate the 7 performance areas. So the customized UPCAR index draws from the World Bank's IBNet UPCAR index, but with some little minor changes to be customized to the local conditions. And again, here we see the ones that are below critical level, but those who are above the normal level. So there are different levels that are defined, and we can see the current status and situation in terms of performance of each utility. And we can see the total picture here and the total average, but we see that there are quite big differences among the utilities. So we try to matchmake the good performing utilities with the bad performing eventually, and try to create a platform so that the utilities learn from each other. And this is another chart that we create to see per performance area. As I told, we have 7 performance areas, and see this is a sector-wide picture, by the way, but we produce also charts per utility, but we see that the energy efficiency is relatively underperforming, while drinking water services is a better performing performance area. And we also ask the utilities to report and provide good practices that they apply on the ground. Technically also relates to human resource and financial management, as well as customer services. So to see what are the underlying practices and cases and factors that contribute to the good performing indicators, so that the other utilities could make use of. And overall, based on our studies, I think we could share some success factors in these kind of studies. So we need, this is common sense, of course. We need a good planning with a clear roadmap. But I think the most important part is to be able to convince the top management that this is a value-adding exercise, since these kind of exercises are mostly done on a voluntary basis. So the top management, I think, is critical here to be reached out, and so that it trickles down to the staff. And we need a good quality data and management systems. And we cannot just simply copy the practices from abroad. We should definitely customize and adapt these concepts to local conditions. And we should also be able to select comparable benchmarking partners. So in Turkey, we didn't have that problem because we have chosen the utilities that have the same status. And we need here also a quite dedicated project team that focus on all the details. As I told, it's quite a detailed process that requires a lot of efforts. And our reports are available on our website. Unfortunately, it is in Turkish, but we plan to translate these reports into English to be shared with the other countries. So going forward, I think it's good to mention some recommendations that could be relevant for not only for Turkey, for other countries, especially in OIC region. We see that the global water agenda is now quite active, and there are new paradigms arising. So new approach should be taken into account in the long-term planning studies and also by the utilities. So we need to inform the utilities on the new approaches that are ongoing. And I think in Turkey we don't have a union, an association for water utilities. So we recommend that there is a association of WASAs. I think in Pakistan there is one, but similar to other countries, a water utilities association would be important to create a direct platform that is relevant for the utilities. And also considering the economies of scale, joint solutions should be formulated instead of single solutions, especially in drinking water and wastewater systems, especially in rural settlements. That's what we have seen in Turkey. So we should have to expand the scope of the WASAs to include other small settlements. And the study, the benchmark concept could be applied to other municipal services such as solid waste management and air pollution. So that is our advice for the municipalities. And one thing I think that is missed is that the performance assessment, the evaluation is focused too much on the data reporting. But we should somehow come up with a performance improvement study and an action plan that focus on performance improvement, not only just evaluate the current situation, but we should come up with an action plan with for performance improvement. Sorry. And we also advise the governments and are also government to maybe to consider the benchmarking studies to be a requirement to be publicly shared with the citizens and to be associated with the master plans. And we as Suan are ready to share our experiences in benchmarking, and we also are ready to be involved and lead if necessary in a benchmarking study to be conducted with OIC countries. I think I can conclude here. I try to be fast as possible to meet the 25 minutes limit. And if you have any questions, I will be happy to answer. Thank you very much.
If anyone want to ask a question. So my question is about, thank you very much for your benchmarking and the relevance in the Pakistani context and issues which we are facing in Pakistan. So if you would like to enlighten us about the water pricing in the Turkey and its impact on the water utilities efficiencies, as we are facing the lower water pricing in Pakistan. In Pakistan, we are facing the Pakistan water is a free commodity in Pakistan. So it has a negative impact on our water utilities. So what is your criteria about the water pricing in this benchmarking of the water sector? Thank you. You are not audible.
Sir, your mic is off.
I couldn't hear the last part of the question. Could you repeat?
Okay. What is the criteria of your water pricing in the Turkey water management and its impact on the water utilities or overall the water management sector? Because
Sure.
we are facing Pakistan. In Pakistan, we are saying that water is considered to be a free commodity. So that is why it has a very negative impact on the water management. So what is the criteria, the benchmarking mechanism of the Turkey water sector? So if you would like to enlighten us.
So when it comes to water pricing, I think it's good to make a distinction between the agriculture water pricing as well as drinking the municipal water pricing. So they have two quite different processes to be approved. So for drinking water services, as I told, the WASAs, the Water and Sewage Administration in Turkey, are part of the municipalities, and each municipality has a general assembly that is gathered twice a year. And so, based on the regulations, the utilities come up with a yearly plan, which estimates all the operational costs as well as the capex. So they come up with a budget, and then they come up with a proposal for the tariffs, the water, drinking water, as well as sanitation, wastewater tariffs, to be approved by the General Assembly of the municipality. So eventually they get this approved, and mostly, based on our studies, we have to a certain degree we have a cost recovery. So it's not, of course, not free. In Turkey, I can show in the reports that the portion of the bill, the water and services bill, is around 1.52% of the household income. So it is not high, yet it's not low. So it is reasonable, we could say. And same goes for Istanbul and other cities as well. So there is a regulation that is quite strictly applied. But again, the General Assembly is made up by it's a political body, so it has some political aspects. But when it comes to drinking water services, I think that that political touch and impact is limited. So they mostly abide by the proposal of the WASA themselves. And by the way, they update it if necessary within the year. So they have it, as I told, they gather twice a year. So the tariff can be updated if needed mid-year.
Okay, thank you very much. So, I guess we want to be from the only participants. Please, you dwell the microphone. Thank you very much for that presentation. My name is Martin Rashid. Work in Pakistan water sector. As far as WhatsApp goes in Turkey, in the West, there's a lot of inclination to have public-private partnerships when it comes to water treatment and providing water. What's the situation in Turkey? You were saying as General Assembly, etc. Are WASAs all publicly owned? Or government?
Yes, as I told, they are 100% public owned entities that are part of the municipalities. They have their own budget, but yet they are owned by the municipalities. But private sector involvement is quite high. So there is a high level of private sector participation in the operation maintenance, for example, of the wastewater treatment plants. Of course, they have BOT arrangements for different structures and facilities for the utilities. So they acquire and quite a lot of services from the private sector. But eventually, the WASAs are publicly owned 100%, and so far there's no plan to privatize. So it seems to remain so.
Yeah, I just want to say that I lived in England in the 1990s, and all the water companies were privatized, and the quality of service went down, but the prices went up, and it's still they're still arguing whether it was the right thing to do to privatize. So I get your point. There is private sector involvement, but not that much that it affects the prices.
In the 90s, there were some concessions given to the private sector. So that was the highest form of private sector involvement. But there were not so good experiences, mostly arising from bad contractual arrangements. So that, of course, bad experiences have impacted the policy and approach towards the private sector. So now the role is more on contracting out the services and the constructions rather than giving concessions. So, but that might change in the long future. But I think it is a quite unlikely situation to happen. So it will remain this way.
Okay, thank you.
Welcome.
Thank you, Mr. Mustafa from SUN.
There is one question in the chat box.
That was almost the same. Yeah. Okay. So our next talk is Transboundary Water Governance and Water Diplomacy by Dr. Tubba Evrim from Water Institute SUN. So, Dr. Tubba.
Thank you very much. Can you see my screen, full screen? No, I'm sorry, I couldn't share it yet. Just a moment. Sorry for that.
Yes.
Sorry, just a moment. I will make it again. Oh my God, yeah. I try to find the full screen one. Just a moment. Now, can you see it?
Yes.
I think you can see. Yeah. Thank you very much for the floor. First of all, good afternoon, and I would like to thank all the participants for their effort and their time. Thank you very much. I would now today I'm the Policy Development Coordinator at Turkish Water Institute, and I will give a presentation about the transboundary water governance and water diplomacy. And I know I have a limited time, and now I started. First of all, I will skip the slides because all we know what's water scarcity. But I would like to say there is only in a global level there is no only a physical water scarcity. Also, there is a economic water scarcity. There is a two different definition, and in some regions of the world, we can experience both of them at the same time. But especially in semi-arid area like Turkey and the Middle East and the Mediterranean region, mostly we experience the physical water scarcity, especially nowadays because of the climate change impacts on water resources. I would like to show the map, and then I will. Yes, transboundary waters is our main issue. All of you know, transboundary waters are of great significance globally and estimated, as you've seen at the map, more than 300 transboundary rivers and lakes, and more than 600 aquifers are utilized by two or more countries, and a total of 153 United Nations member countries are reliant on water. And as you know, transboundary rivers alone account for 60% of the world's freshwater flows, and also has a these basins are home to more than 3 billion people all around the world. So all we know, transboundary waters issue is a matter, and it's important when we talk about the relations between the riparian countries and in some regions in regional level. So there are some, of course, you know, there are some rules like Helsinki rules, and there are some global agreements about 1997 United Nations non-conventional water, non-navigational water use Protocol and also 1992 Helsinki Protocol. These are deals with the transboundary water issues. But as you know, there are customary law. There are some principles about the transboundary water governance. One of them is equitable and reasonable utilization. The other is obligation not to cause significant harm. And the other is the duty to cooperate. And most of the countries, especially like Turkey, these principles are the important pillars of the transboundary water policy of the countries. And this is the map. And I would like to show you that, a few months ago, there is a report published by the UN Global Water Bankruptcy, and they show there are some figures that shows the, agriculture total withdrawals. There is a overlaps between the transboundary water basins and the, most water withdrawals in the all around the world. Also, these are the other risks across the globe, and you can see there is an overlap, especially with the transboundary water basins map. And I would like to, before the transboundary water governance, I would like to talk about the water diplomacy. Of course, water diplomacy is related directly with the country's state's political will. If you want to cooperate, if you want to cooperate on the water issues, of course, water diplomacy is an important tool to develop the dialogue, especially among the countries. So, what is water diplomacy? Water diplomacy refers to use diplomatic process and tools to prevent, manage, and resolve existing and emerging disputes over transboundary water resources while promoting cooperation, strengthening water resilience, and also prosperity. And why water diplomacy matters? As I mentioned before, and during 2 days, most of the participant speakers mentioned about the water issues, water problems, and water challenges all around the world. Growing water scarcity, as you know, and climate change impacts. Climate change impacts is a great challenge for all the countries, especially in semi-arid areas. But it's also opportunity for create a cooperation basement for the countries. Population growth, increasing water demand, and rising pressure on, as you know, transboundary rivers and the aquifers. And water diplomacy, a preventative approach. It's the approach, preventing disputes before they escalate, building trust among riparian states, facilitating dialogue and cooperation, supporting regional stability, and promoting peaceful solutions. Water diplomacy is not signing an agreement protocol. It's a process. Under this process, if the political will of the or interest of the countries will cause a signing an agreement or a protocol, yes, it will be. But water diplomacy is a process, not signing an agreement and protocol, I would like to mention. And main tools of the water diplomacy, one of them is diplomatic tools. Most of us aware of this: bilateral negotiations, multilateral negotiations, mediations. In some countries have some red flags about this issue, but mediation can be a tool for the basins to basin, it's different. And good offices, confidence building measures, and cooperative tools, joint fact finding missions, dialogue platforms, expert exchanges, capacity development programs. And institutional tools are joint communities, river basin organization, or permanent cooperation mechanisms. And what is transboundary governance? Transboundary water governance refers to process, institution, legal frameworks, and cooperative mechanisms through which countries coordinate the sustainable use of transboundary water resources and general mutual benefits. And as I mentioned, like in water diplomacy, cooperation, institutions, rules, joint planning, benefit sharing, and conflict preventations are the transboundary water governance tools also. But of course, sometimes when we use these concepts, they are sometimes it's similar, and the pillars of these concepts are similar, but there are some differences. Water diplomacy is political process, focus on dialogue, especially with the water diplomacy. We try to create a common language between the stakeholders. Maybe they are riparian states, sometimes in regional level and at every level, and conflict prevention, and try to build trust among the riparian countries, and they use the diplomatic tools also. In the transboundary water governance process, focus on management, use of these sustainable and technical tools. And these are the not all of the transboundary river basins, but these are the examples of the transboundary river basins. For example, Rhine River, Euphrates River, Jordan, Mekong, Nile, Brahmaputra, Danube, and the Rio Grande. And there are some different kind of tools are used in that basins for the sustainable use of the transboundary waters. For example, in Rhine and Danube River, they are very good and popular examples when we talk about the river basin organizations. But the properties of the basins are different, and also priorities and the usage of the river basins are different. Yes, they can be not a model but inspiration for the other basins, but they are not a absolute framework for implementing these frameworks to the other basin organizations or for the basins or other basins. For example, in Danube River, navigation is one of the main issue when we talk about the Danube River. And when we look at the history of the Danube River, it's more than 100 years ago they start to cooperate on that issue. And also Rhine River. One of the main issue is also navigation. The other issue is the pollution. And this is the reality. We totally get this information from our experience. If there is a quality problem, the cooperation can be much more easier when we compare with the basins which has quantity or allocation problem, because quality is in the quality, when you solve the quality problem, there is a win-win solution for all the riparian or relevant countries. If we talk about the navigations, also we have to talk about the relevant countries. But if we talk about the basins, water basins, which is only used for the agriculture or drinking or which are not used for the navigation, maybe in general, we talk about only riparian countries when we talk about the cooperation or the mechanisms and the other issues. For example, as you know, I will mention detailed in Euphrates and Tigris River Basin, there will be of course, quality is another issue, but the main issue is the water scarcity in the region. In Jordan River also. In Mekong River, this is also another kind of priorities. For example, fishing for the fisheries, it's much more important when we compare with the other basins. These are examples, and there are different kind of solutions in that basins. Because of the regional stability, maybe because of the geography, maybe the neighbor history. Sometimes the relations among the countries is also create a framework. What kind of framework that you can create for these river basins? For example, in Turkey, Euphrates and Tigris River, yes, we have a joint technical committee we created in the 80s. It's not the river basin organization, but we have a joint technical committee. But because of the, wars, conflicts, and the instability in the region, there are sometimes continuity problem about this kind of institutions. These are some examples about this issue. And I would like to skip this slides because Ms. Nazlı mentioned about what's the water situation in Turkey. These are the basins. And I would like to give a little bit information about what is our national perspectives about this current climate and water priorities. For example, as the Ms. Nazlı mentioned, water law is prepared now. And implementation of European Union Water Framework Directive, as you know, I don't know, but we are the candidate country of the European Union. So implementation of European Union Water Framework Directive and Flood Directive is a must for Turkey. Water efficiency strategy document, I can skip because Ms. Nazlı also mentioned it. Also climate law, climate change adaptation strategy action plan, basin scale flood and drought management, the Green Deal, agricultural law, and also national water plan these are national legislation about the water issues. And I would like to pass also because also the other speakers mentioned about the Turkey's situation in the next feature about due to the climate change. And I would like to give information about our transboundary waters. Turkey has 5 transboundary water basins, and 2 of them we are downstream and 3 of them we are upstream countries. In Maritsa Basin we are downstream countries. In Çoruk we are upstream countries. Araskura we are upstream countries. As you know, Euphrates and Tigris we are also upstream countries. And in Orontes Basin we are downstream countries. And Turkey's transboundary water potential is nearly 40% of the Turkey's water potential. It's very important due to the water potential, and also it's very important for the hydropower capacity of Turkey, because as you know, we are not a fossil resources rich country. For the energy security we need hydropower also, and the transboundary basin has a more than nearly half of the hydropower capacity of Turkey when we talk about the transboundary basin. And these are the dams also. And in transboundary water policy, we have some institutions who deal with this issue directly. One of them is Ministry of Foreign Affairs. Under the Ministry of Foreign Affairs, there is a special department about transboundary water issues. Also, in our ministry, under the Ministry of Agriculture and Forestry, SUEN, Turkish Water Institute, State Hydraulic Works, and General Directorate of Water Management are responsible organizations about the transboundary water policy. And also I would like to give some examples. When I'm talking about the water diplomacy, I will pass this track 1, track 1.2, track 2, and track 3. These are the tools under the water diplomacy. These are some ways how can we come together, how people come together under these umbrellas. For example, in track 1, this is officially binding process, and as a Turkish Water Institute and the other organizations deal with the water issues, we can attend all that kind of meetings, and this is traditional diplomacy. As you know, government officials only attend this process. Negotiations is also another tool. Cooperation is one of the political will. Legal documents are the output of these processes, and result outcome oriented. And also track 1.5, also we officially support that kind of process, because in track 1.5 this is semi-official, non-binding process. Government officials also can attend this process, and there is also non-governmental representatives. The meetings are important in that process, and the main issue is developing dialogue, capacity building programs, open to change and open-ended process, and networking is another issue under this process. And track 2 and track 3 are the non-official and non-binding. These are for the academicians and non-governmental representatives. But as Turkey, we are always involved track 1 and track 1.5. I'm talking in an official level, of course. Of course, track 2 and track 3 are, of course, followed by the other non-official organizations, but we also give importance, especially track 1 and track 1.5 process during our negotiations with our neighborhood on transboundary water issues. Turkey's transponder water policy. Turkey considers water as a source of cooperation among riparian countries. And as I mentioned before, especially in the customary law that mentioned equitable and reasonable utilization, not giving a significant harm, and duty to cooperation are important pillars of the Turkey's transponder water policy, and we believe that transponder river basins have their own characteristics and peculiarities, and each case of the transponder waters reflects specific regional, economic, social, cultural, and historic aspects. So there is there must be a tailor-made models for the transponder basins when we try to use this water in a sustainable way. And we in Turkey transponder water policy, we believe that the water issues should be addressed only among the riparian countries. There is no need to third parties in that process. And also, as I mentioned, significant harm and equitable, reasonable, and optimum manner using water resources is also another our official policy. And our transponder context, water vision transponder context, of course, as I mentioned, we are upstream and also downstream country. And water diplomacy is a strategic pillar of the Turkey's foreign and development policy. And our focus is cooperation, resilience, and welfare of the basin or the region. And as I mentioned, equitable and reasonable use and no significant harm, but also we encourage joint projects with the riparian countries. Especially also we are shared benefits, and we are focusing on also shared responsibilities. Every riparian countries has the responsibilities. Not only upstream countries has responsibilities, also downstream countries has responsibilities on using the water in an efficient way. Not only this is not the only upstream countries' responsibilities. So also strengthening technical cooperation, data sharing, sometimes joint monitoring. Data sharing is still a problem among the riparian countries. It's not about our basins, also the other basins we experience this. Yes, especially collecting reliable data is a problem. And there must, first of all, we have to collect the reliable data. And for this, maybe we can support each other for the technical cooperation or know-how sharing, but we have to, first of all, we have to collect reliable data, and then we can pass through to the data sharing and joint monitoring. Also early warning system, especially in the flood periods and also drought periods, but drought is a period, but floods are very flash in a minute it can occur. So early warning systems are important when we talk about the transboundary water governance, and promoting climate resilience related models on water resources, because this is another important challenge. And nowadays Wi-Fi Nexus is very popular concept, and we try to do our best under this umbrella. But as a Turkey, water aligned agriculture, irrigation modernization and efficiency, nature-based solutions, clean energy, floating solar on dams, and building cross-sectoral partnerships are our activities under this Wi-Fi umbrella. And we have many experience in that issue, and we are ready to share our knowledge with the riparian countries, not only with the riparian countries, also neighborhood regional countries. And water diplomacy is another issue. It's a confidence building tool. For example, Turkey-Iraq Framework Agreement on water cooperation is important tool between Turkey and Iraq, especially on Euphrates and Tigris River basin. Blue Peace Middle East dialogue platforms, also we involve that kind of initiative platforms who focusing on the trust building among the countries. And capacity development programs are as another issue, especially as a Turkish Water Institute. We have under the Swen Academy, we we prepare many capacity building programs, not only for the riparian countries, also for the regional countries, and enhancing technical cooperation and mutual trust are the important key for the Turkey. And I will have to, how many minutes I have? Okay. And I would like to give examples about the Euphrates and Tigris Basin. What's the process that we do? But I try to keep short. And as in the Euphrates and Tigris Basin, Turkey, Syria, and Iraq and Iran also are the riparian countries. Iran's situation is different because Iran is the upstream country when we talk about the Tigris River tributaries. But in the basin hydrological map, Iran is one of the riparian of the basin. Just a moment. Why it is finish. And these are the open data. These are not the classified data you can find from the literature easily, but most of the Euphrates water is coming from Turkey, and 40% of the Tigris River is coming from the Turkey, originate from the Turkey, and totally 60% of the water of the Euphrates and Tigris River basin origin from Turkey. And there are, of course, major political turning points in the basin. We couldn't dismiss it because these are also has a great impact, water cooperation and water relations among the countries. These are the political turning points in the basin. And these are the agreements. I will pass it. But this is a timeline, especially which shows relations among the riparians in the ET basin. It is started from since 1920s. And you can show the reds are the agreements. The blues are the process also. And with the Iraq, for example, that I'm given that example, 2024 framework agreement, water framework agreement, is an important step and tangible step which is taken by Turkey and Iraq on water resources. And also we have crisis in the basin, especially the impounding process of the basin, of the dams are critical in the basin history. And these dams are mostly used for the producing hydroelectricity. As you know, Euphrates and Tigris Basin is a vital source for all the three countries, and the primary use is agriculture. So when we talk about the sustainable use of this basin water, we have to focusing on the water efficiency, especially in the agriculture sector. And as a Turkey, we believe that water unites principle. So water is a tool for cooperation, not a conflict or weapon in the conflict or war period. And we believe water unites and it causes a shared prosperity in the basin. And these also, we have common challenges, climate change, hydrological shifts, and we are all water stress country. All the riparian countries are the water stress countries, and we have cooperation opportunity, and we can use scientific information, scientific base for the cooperation. In this regard, Turkey and Iraq has technical cooperation on water because when we use a water diplomacy tool, we need scientific information for the understand the real situation. And as I mentioned, we have a joint technical committee and we have strategic memorandum of understanding which are signed in 2009. And we have also special envoy on Iraq issues, former Minister of Water and the Forestry, Professor Erol, is a special presidential envoy on Iraq issues since 2018. And also, we have some case studies, especially Ilısu Dam, because Iraq has many concerns about the Ilısu Dam, especially in the impounding process. But in 2018 and until the 2020, we have a good relations and communication about the impounding process. And because in 2018 it was a drought period, and Iraq want Turkey to postpone the impounding process of the dam, and Turkey postponed the impounding process of this dam. This is a good example for the communication, for showing the communication importance between the riparian countries. And as I mentioned, water use efficiency is one of the important issues when we talk about the sustainable use of water, especially in the transboundary water governance. Infrastructure modernization, especially in conflicted area in Iraq and Syria. Water networks are damaged, so it must be modernized and rehabilitate, sometimes rebuilt again. These are important for the water saving. Also, storage benefits is also important because Turkey's valley is much more implementable for the water collection in the valleys. Also, multi-track diplomacy. And we have, as I mentioned, framework agreement with Iraq, which was signed in 2024, and this is approved, ratified by the two countries, and we are now in the implementation process. And we have also extra new document for the implementation process, especially financing of the projects. So we are now waiting for the approval from the Iraqi new government, because in that time there was an election in Iraq, and now the new government now established. Now we are approval from the ratification from the new government, and then we will start to implement the agreement. But we start this implementation of the agreement with starting with capacity building programs and joint monitoring of one of the tributaries of the Tigris River basin. Also, we have held many field trips to the Iraq to understand what's the water efficiency situation in the agricultural sector. And what the path forward, political will is important when we talk about the transboundary water governance. First of all, maybe there are nice agreements, maybe there are strong frameworks, but the implementation is very problematic. Since 2024, in the water events, we talk about this issue. There are lots of documents on the paper. They are perfect and they are signed documents, but if there is no political will, the implementation process is problematic. Also, action-oriented solutions. Yes, we talk about water everywhere, and it's a sometimes very important discourse. Wow, but we discussed the implementation process. It's much more problematic. Sometimes about the political will, sometimes about the capacity building. Sometimes it's about the investment. So we have to take tangible steps when we talk about the transboundary water governance and stability through water. It's enhanced technical cooperations, fosters political trust and regional stability. This is my presentation. Thank you for your attention. If you have some questions, we can elaborate. Thank you very much.
If any question from my participants? Sorry, again, it's for the, let's check this. You mentioned cooperation when you're managing transboundary water. You must be familiar with the Indus Waters Treaty and what happened last year, because India unilaterally suspended the Indus Waters Treaty, and it nearly led to a conflict between our countries. So diplomacy works usually, but in this case, diplomacy has failed. In this treaty was brokered by the World Bank. So do you see a solution forward in such a situation when two neighbors are not all willing to talk to each other?
I try to understand, but I can hear the keywords. You ask me about the India and the Pakistan situation, about the agreement, 1960 agreement, and how can we solve the problem? Yeah, many years later, after last year, yeah, there is a as we know from the newspapers and from also from the water experts from your countries, yeah, as we know, there is a problem now about the implementation process of the agreement because of yeah, India, especially India doesn't want to implement this agreement. Yes, this is a new issue. Uh, how can water diplomacy? First of all, there is a you have to come together. This is my personal opinion. This is my personal opinion. Maybe and you have to discuss. Maybe you can use the track 1.5, not the starting with the official, because now the cooperation is stopped, as I understand from you. They didn't implement the agreement. Maybe you can start with the non-binding process, especially with the track 1.5, come together and try to understand each other, and then maybe after these track 1 point initiatives or meetings, you can with the results of these meetings, maybe you can support the official meetings, because in an official level, there are directly said we don't implement this agreement, as I heard, if there is no changes, as we heard from the news and the other from the literature. But I think first of all you have to talk in official. If it is impossible in official level, maybe with the track 1.5 you can start to talk each other.
Okay.
This is my personal opinion also, I have to say.
Track one diplomacy, track two diplomacy. I hope we can, because we've indulged in track one, track two diplomacy. But no headway has been made.
I couldn't hear you, I'm sorry.
We have had track one and track two diplomacy, but the
Mm-hmm.
way the governments are facing each other now at the moment, I don't think we are in any way ready for a compromise. Maybe
Okay,
in
okay, I understand now. I understand, yeah.
Okay, thank you. Thank you, Dr. Kuba, for the concluding remarks.
So first of all, I want to thanks to our chair, Engineer Syed Ayaz Mohammed Haider. He is a civil engineer, water sector specialist, project management professional with over 15 years of experience. And he is currently serving as a director monitoring at the Ministry of Water Resources. So thank you, sir. Thank you, Ms. Toba, co-chair this session and for her insightful presentation. So I would like to invite Mr. Mustafa Sirikaya from Turkish Water Institute for the concluding remarks.
Yes, hello again. Thank you very much. I think it has been a short but effective event, and we appreciate the leadership of COMSTECH and the leadership of COMSTECH in water related affairs. Last year, I attended the meeting for the network of water research centers, which was also a quite effective meeting. And I think this is a follow-up event of that event, and we look forward to work together with COMSTECH, not only as SUEN, but also as a ministry on different aspects of water management. So this one was focusing on water governance. As you know, water governance can be sometimes vague, by definition. So I think by giving some concrete examples from Turkey, but also learning from the examples and practices from other countries have been very effective and quite learning for us. And we also appreciate the professors from other countries. As you know, water governance is not an end itself. It's a means to achieve good water management. So we should, I think it has been very smart to start with water governance as the first training topic of this year, but we would also are willing to continue with other aspects. And IWM is also an important aspect, and we place a lot of importance on this concept by practicing it on the ground. I think it is important that IWM draws also the attention to demand side management by benefiting from innovative instruments as we do in Turkey. So we don't only focus on supply side water management, but we also focus on the demand side. That I think what IDBRAN brings a value to the table, and it shouldn't be seen as a prescriptive description of how water should be managed, but I think it provides a broad framework in which decision makers can collaborate and decide on the goals of water management in their contexts. So what I have taken away from the speakers that we should prevent to work in silos, and we should have diversity and different perspectives in water management. So, however, on the other hand, it is a holistic approach, but it should somehow touch the grassroots level. It should touch the ground. That I think that's also one of the takeaways that we had from this training program. And of course, given there were different angles and perspectives, and we couldn't cover all the aspects related to water management either. Of course, given the time frame, and we haven't touched upon topics like legislative aspects, information management tools, AI tools, water pricing, and other aspects of the implementation of IWM. So these could be addressed in future webinars in the future. So we are very supportive to be part of those kind of events. And finally, I would like to highlight the Water Council. I don't know if all the participants know about it. It is a council that is formed under the OIC as a critical platform to work together on water issues. And it was established in 2016, as far as I can recall, as a result of the third meeting of the OIC water ministers in Istanbul. And there were 4 elements that were designated as cooperation areas. And indeed, capacity building was one of those. And I think the OIC Water Council, in the leadership of COMSTECH and other relevant OIC institutions, can be further utilized for future collaborative works in the water sphere. And I again, on behalf of Turkish Water Institute and my colleagues, we would like to thank again everyone who participated for their interest and for their contributions. And we hope to stay in touch by sharing knowledge and experiences. You all have our email addresses, and we're always ready to answer any questions and also learn from the other countries. And we thank you very much again for the great event. By the way, we have also another partner, the GD of Water Management, and Mrs. Huriye is here, I believe, and she could say some words as the other partner in this event. If you could allow her, she could also say some words, some concluding remarks. Miss Huriye İncelik Ceylan.
Okay, let me find her.
It starts with Turkey, by the way. I think Turkey.
Yes, yes. So, yes, so she has the mic. She can unmute herself and please.
Yes, this is Suriye. I hope you could hear me properly.
Yes, yes, please.
Thank you, dear colleagues. It's a great honor and pleasure for us to attend this fruitful and comprehensive study. This is one of the most important series of COMSTECH. I would like to convey my appreciation, COMSTECH, and my our bilateral partner Suan for this comprehensive program. And for 2 days, you know that me myself following the program, and my colleagues give smooth and comprehensive contributions regarding the IWRM and water governance and the other management practices of Turkey's perspective. In this manner, you know that Turkey is one of the water scarce and climate vulnerable countries in the world because of late depending on the Mediterranean country effect. And this is our most important situation, that we all know that water is not a merely nature resource. It's the foundation of economic development, food security, energy production, public health, and environmental sustainability. In the face of climate change, our Turkey and our countries all increasing water demand, population growth, and rising drought risks, and extreme weather events, as you know. To be an answer corresponding to climate change, Turkey is willing to participate in water management studies and programs, and to follow up the bilateral and multilateral cooperation regarding the water management issues. And today we are very happy to be with you and to be part of this important activity. And we hope that we will follow this partnership regarding the bilateral negotiations depending on different issues except water governance. Maybe we can negotiate on future time upcoming process regarding the water issues, which we follow up the process. And I know that investing in water is an important partner of our water governance issue. And the decisions we make today will determine the availability, quality, and sustainability of water resources, I believe, in this issue. And to follow up, not lastly but not least, I would like to thank for your participation and for your attention, because these presentations all of were very important and very fruitful from our perspectives to come a common ground regarding the water related issues. On behalf of my institution, General Directorate of Water Management, I would like to thank you for your attention, and hope to meet you again for upcoming events. Thank you.
Thank you very much, Ms. Puria, for your remarks. On behalf of COMSTECH, I would like to thank you. We were expecting to have Professor Dr. Iqbal Chaudhry with us, but he's engaged in another meeting. So on behalf of COMSTECH, I would like to thank our partners, the Turkish Water Institute, as well as General Directorate of Water Management, Turkey, their speakers, their organizers, for taking out their time and for commitment to making this training a good effort all together as a hybrid event. I would also like to thank particularly Mustafa Sarakaya, because we have been going back and forth on the program and many other aspects of organization, for his patience and for his prompt response every time. Other than this, I would also like to thank our chair and co-chair who were present here with us on both days. Right now we have Engineer Ayaz Sam with us. Thank you very much, sir, for your valuable contribution as the chair. And I would also like to thank our speakers who joined us from Malaysia, from Bangladesh, from Jordan and other countries. With this, I would like to emphasize here that COMSTECH is one of the member institutions of the OIC system who is working on water-related issues. So in the coming months and years, we hope to have more water-related training and capacity building with our partners such as SUN and GDWM. So we hope that the participants who have joined us here in this meeting virtually as well as in person, you will stay connected with us through our website, through our social media handle, as well as through peer-to-peer approach, so that we can work collaboratively on water-related issues. With this, I would now like to request Engineer Ayaz Sahab to kindly give certificate of participation to our in-person participants as token of appreciation for their time and for coming here. Please welcome Mr. Ayaz. So first I have Mr. Muhibullah. You have to clap for yourself. Ms. Maniza Gul. Ms. Naila Irshad. Mr. Wasif Rashid. Mr. Shehbaz Bukhari.
Right. One.
Mr. Farooq Abbas. Mr. Parvez Nasser. All the online participants, they will receive their certificates within 10 to 14 days. Thank you very much for joining us. Thank you again. Bye-bye.